coordinate geometry. This is 7th chapter. In some state it could be 5th chapter, or in some state it could be 10th chapter also, but the portion, the syllabus are same only. So what is coordinate geometry? Coordinate geometry is nothing but it's a study of points, lines, polygons, etc. on an xy plane. So xy plane you already know, there will be x-axis, there will be y-axis, and between x and y-axis there could be point, there could be line, there could be triangle, there could be square. So we'll be studying all these in this coordinate geometry. Okay, actually in coordinate geometry there could be 3 axes also, x, y and z axis. If 3 axes are there, then we can study 3-dimensional objects also. But here for your standard only coordinate geometry in xy plane only has been prescribed. So we'll be dealing with points, lines and polygons in an xy plane only. There's no z axis. So first thing that we'll study here is distance formula. Now consider one xy plane. This is x axis, this is y axis. Consider a point here whose coordinate are a 3, 2. Now I'll draw one perpendicular from a to x axis. Okay, and also I'll draw one perpendicular from a to y axis. I'll join O and A. Now what is the length of OA? Now you can see OAB is a right angle triangle. Now if we apply Pythagoras theorem here, square of the hypotenuse is equal to sum of the square of the other two sides. That means OA square, OA is the hypotenuse, therefore OA square is equal to OB square plus BA square. OB is 3 units here. Okay, 1, 2, 3. So 3 square plus BA. BA is nothing but equal to 2 units. Here you can see. So BA I'll take 2. So BA square is 2 square. So 3 square is 9. 2 square is 4. So 9 plus 4 is 13. So OA square is equal to 13 I'll get, or OA is equal to square root of 13. So this is the simple distance formula of a point from the origin. So in the textbook also this explanation has been given. You can see here distance formula. Now consider a xy plane. So this is x axis and this is y axis. This is the origin O. Now consider one point P whose coordinates are x1, y1. Now consider another point Q whose coordinates are x2, y2. Now what is the distance between P and Q? How to find it? It's very simple. I'll draw one perpendicular from P to the x-axis, and I'll draw another perpendicular from Q to the y-axis, and I'll draw one perpendicular from P. Okay, I'll name this as R and S. Okay, so perpendicular means this is 90 degree, this is 90 degree, and I'll draw one perpendicular from P to QS. Okay, like this. Okay, and I'll call this point as T. Now what is the length of PT? You can see what is the length of PT. Length of PT is given by, okay, length of PT is this length minus this length. Okay, that is length of PT is equal to length of OS minus length of OR. Okay, so what is length of OS? See, coordinates of point Q is x2, y2. Therefore OS is x2, and coordinates of P is x1 y1. Therefore coordinates of therefore length of OR is nothing but x1. Okay. Now similarly, what is the length of QT? Length of QT. Length of QT, that is this length. What is this length? This length is given by this length minus this length. Okay, that means QT is nothing but QS minus TS. Now what is length of QS? So see, coordinates of Q is x2 y2. Therefore the QS is nothing but y2. Okay, if I draw one perpendicular from Q to y axis, then QS is nothing but y2. Okay, and what is TS? Now TS is also equal to PR. Okay, PR, because TS is equal to PR. Now y2. Now what is PR? See, now I will draw one perpendicular from P to the y axis. So PR is nothing but y1. Okay, so QT I will get y2 minus y1. Now in triangle PQT, see, in triangle PQT, angle T is equal to 90 degree. Therefore it's a right angle triangle. Therefore applying Pythagoras theorem, I will get square of the hypotenuse. PQ is the hypotenuse. PQ square is equal to sum of the square of the other two sides, that is PT square plus QT square. So what is PT? PT we just derived from 1, it is x2 minus x1, x2 minus x1, the whole square, plus now QT I found that it is y2 minus y1. This I am marking as 2. So y2 minus y1, the whole square. Or PQ I can write as PQ is equal to square root of x2 minus x1, the whole square, plus y2 minus y1, the whole square. So this formula is called as distance formula. So distance formula is simply nothing but the distance between 2 points on an xy plane. What are those 2 points here? P and Q. Suppose if P is the origin, that is, if coordinates of P is 0, 0, then what will become PQ? PQ will be equal to square root of x2 minus 0, the whole square, plus y2 minus 0, the whole square. So or simply it becomes square root of x2 square plus y2 square. So this distance formula I will mark it as 3 and this I will mark it as 4. So 3 and 4 both are distance formula. 3 gives the distance between any 2 points on an xy plane. 4 gives distance formula of a point from the origin. If P is 0, 0, then this is OQ. Okay, this is OQ. OQ is equal to square root of x2 square plus y2 square. So that means it's like this. Q is here, x2, y2. The distance of OQ is given by square root of x square plus y2 square. You can go through the text. I have given the same explanation as in the text. Now here you can see in the xy plane here there are 2 points P and Q. So ultimately when we derive the distance formula, we'll get the distance between point P and Q is x2 minus x1 the whole square, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So there are some worked examples here. In this one we should check whether these 3 points form a triangle or not. All are self-explanatory, you can go through it. In this problem you can see whether we should check whether all these 4 points make a square or not. So in a square all the 4 sides are equal and the diagonals are equal. We can check it. So you should make a habit of reading a maths textbook. So go through it, all are self-explanatory. I'll be solving exercise problems. So distance formula, we just now derived that it's equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. I'll mark this as A. Now I'll write the same equation little differently. Now x2 minus x1 the whole square I can write as minus of x1 minus x2 the whole square. I have effectively made no change. When you open the bracket you will get same thing, x2 minus x1 only you will get. Now here y2 minus y1 the whole square, here also I will make some changes. I will write minus of y1 minus y2 the whole square. Again here also if you open the bracket you will get the same thing, y2 minus y1 the whole square you will get. So effectively I have made no change in the equation. Now this is equal to, now here my minus means it's minus 1, okay, minus 1 into x1 minus x2 the whole square. There's no change in the equation, you can observe. So this is minus 1 into y1 minus y2 the whole square. Now here I can write this as square root of minus 1 the whole square into x1 minus x2 square plus minus 1 the whole square into y1 minus y2 the whole square. I can write this way. Now here you can see minus 1 the whole square minus 1 the whole square is equal to minus 1 into minus 1. Minus 1 into minus 1 is plus 1 I will get. So this becomes plus 1 into x1 minus x2 the whole square plus here again 1 into y1 minus y2 the whole square. Now here ultimately I will get square root of 1 into x1 minus x2 the whole square is x1 minus x2 the whole square itself, and here I will get y1 minus y2 the whole square. So this I will mark as equation B. Now what is the difference between A and B? Both are same only, but x1 and x2 are interchanged, that's it. But the value of the distance, value of the equation doesn't change at all. So you can interchange the value of x and y. At the same time you should compulsory interchange the value of y1 and y2 also. You can't interchange x1 x2 and leave y1 y2 as it is. In both the place you should interchange, only then you will get the correct answer. Now exercise 7.1, question number 1, sub question. The given points are 2, 3 and 4, 1. Now let P be P of 2, 3 and let Q be Q, Q of 4, 1. So therefore what is the distance between P and Q? Distance between P and Q. So first write the formula. It is given by x2 minus x1 the whole square plus y2 minus y1 the whole square. Now I'll take for P I'll take x1 y1 and for Q I'll take x2 y2. Okay, so x2 is 4 minus 2 the whole square plus 1 minus 3 the whole square So 4 minus 2 is 2. 2 square plus 1 minus 3 is minus 2. Minus 2 the whole square. So this I'll get square root of 2 square is 4 plus minus 2 the whole square is plus 4. Okay. So here square root of 4 plus 4. 4 plus 4 is 8. Now 8 I can write as 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So I can group these two and take outside here. So I can write this is equal to 2 root 2. So distance between point P and Q is 2 into root 2. Exercise 7.1, question number 1, sub question 2. Points are minus 5 comma 7 and minus 1 comma 3. So first point I'll take as Q, second point I'll take as Q. Therefore distance between P and Q is given by, first write the formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is minus 1 minus of y1 is minus 5. So minus of minus 5 the whole square plus y2 is 3 minus y1 is 7 the whole square. So this is equal to square root of, so minus 1, so minus into minus is plus 5, so minus 1 plus 5 the whole square plus, so 3 minus 7 is minus 4 I will get. So 7 minus 3 is 4, sign of greatest sign, that is minus the whole square. So this is equal to, now minus 1 plus 5 is plus 4 the whole square. So plus here minus 4 the whole square is minus 4 into minus 4 is plus 16. 6 6 are, sorry, 4 4s are 16. Okay. Now again I'll get here also 16 plus 16 I'll get. So this is equal to 32. So 32 I can write as, so 32 if I factorize, 2 1s are 2, 6 are 12, 2 8s are 16, 2 4s are 12, 2 2s are 4, 2 1s are 2. So 2 5 times, 2 into 2 into 2 into 2 into 2, 1 2 3 4 5. So I can now group like this, make group of 2's. Now I'll take this outside, I'll take 1 2 from here. So I can write 2 into 2 and the remaining is root 2. So 4 root 2 is the answer. Now sub question 3. The given points are A, comma B and another point is minus A minus B. So first point I'll take Q, second point I'll take as Q. So P cube. So every time it's always better to write the formula. So distance formula is x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is equal to, now x2 I have taken, also point Q is x2 y2, therefore minus A. So x1 is plus A, so minus A minus of A the whole square plus y2 is minus B, minus of y1 is plus B, so y2 minus of y1 is B the whole square I'll get. So this is equal to square root of, so minus A is minus 2A, it's addition. So plus of minus B is minus 2B I'll get the whole square. So this is equal to square root of, so minus 2A into minus 2A is plus 4A square I'll get. So plus 4A square, so minus 2A into minus 2A is 2 2s are 4, so A into A is A square, minus into minus is plus 4A square I'll get. Similarly here I'll get plus 4B square. So here I can take 2 as common factor, 2 into A square plus B square. sorry, okay, 4. Now square root of 4 is 2, so 2 I can take outside. 2 in, this is 2 into square root of a square plus b square is the answer. Exercise 7.1, question number 2. Find the distance between the points 0, 0 and 36, 15. Can you now find the distance between the two towns A and B discussed in section 2.7.2. So first here the given points are 0, 0, 0, 0 and 36, 15. So first point I will take A, second point I will take as B. So now what is the distance between A and B? So this is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is 36, 36 minus 0 the whole square plus y2 is 15, 15 minus 0 the whole square. So this is simply 36 square plus 15 square. Now 36 square is 36 into 36, 6 6 are 36, so 6 3s are 18, 19, 20, 21, then 3 6 are 18, 3 3s are 9 plus 1 10, so 6 9 2 1, so 1 2 9 6 plus 15 square, 15 into 15 is 5 5 are 25, 5 1s are 5 6 7, 1 5s are 5, 1 1s are 1 5, so this is 12, 225, so 1296 plus 225, how much I will get? This is 10, sorry 11, 10 12 carry 1 5, 2 to 4 plus 1 5 1. So this is equal to square root of 1521. Now what is square root of 1521? So 1521, so first I will divide by 2 2s are 4, 3 3s are 9, 4 4s are 16, so I will take 3 3, 3 3s are 9, so 3 3s are 9, 15 minus 9 is 6, so here I will add this 3 again, 3 plus 3 is 6, so here I will take this 22 below 21, then 6 6 8 are 6 9s are, sorry 69 into 9 I will get 9 9s are 81, 9 6 are 54, 54 plus 8 62 I will get, so 0 0 0, so square root of 1521 is 39. Distance between AB is 39. So one more thing they have asked here, can you find the distance between the two towns A and B discussed in section 7.2. So now let us go to section 2.7.2. so in section 7.2, so this is section 7.2. so here there are two cities A and B. A is lying at 0.00 and B is 36, 15. So distance between A and B is 39. So here it is in kilometer, therefore distance between A and B will be 39 kilometers. The distance between cities A and B is 39 kilometer. Exercise 7.1, question number 3. Determine if the points 1, 5, 2, 3 and minus 2, 11 are collinear. Okay, I'll take let P as 1, 5 and Q as 2, 3 and R as minus 2, minus 11. Okay, now what is the distance between P and Q? So formula, distance formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? So now distance between PQ is square root of x2. x2 is 2, 2 minus 1, sorry, 2 minus 1 the whole square, plus y2 is 3, 3 minus 5 the whole square. So 2 minus 1 is 1, 1 the whole square, plus 3 minus 5 is minus 2, minus 2 the whole square. So this is equal to square root of 1 square is 1 only, plus minus 2 square is minus 2, minus 2 into minus 2 is plus 4. So I'll get square root of 5. Now what is the distance of QR? Distance of QR is given by square root of x2 minus x1 the whole square, that is minus 2, minus of 2 the whole square, plus y2 minus y1 the whole square, that is minus 11 minus 3 the whole square. So here minus 2 is minus 4, minus 4 the whole square, plus, so minus 11 minus 3 is minus 14. Okay, so here we will get 4 into 4 is 16, so minus 4 into minus 4 is plus, so plus 16, plus 14 into 14, 14 into 14, 4 4s are 16, 4 1s are 4, plus 1 5, so 1 4s are 4, 1 1s are 1, so 6 196. So addition of these two, 6 6 12, carry 1 9 plus 1 10 plus 1 11, carry 1 2 2 1 2 I'll get. So 2 1 2, if I factorize 2 1 2, 2 1 2 I'll get 2 1s are 2, 2 6 are 12, then again 2 5 are 10, 2 3 are 6. So I can write this as square root of 2 into 2 into 53. So also I can write, okay, let that be as it is. Then what is the distance r? PR. PR is given by square root of x2 minus x1, that is minus 2 minus 1 the whole square, plus of y2 minus y1 the whole square, that is minus 11 minus 5 the whole square. So this is equal to, so minus 2 minus 1 is minus 3, minus 3 the whole square, plus minus 11 minus 5 is minus 16, minus 16. So addition, minus 11 minus 5 is addition, so 11 plus 5 is 16, so sign will be greatest sign, that is minus. So this is equal to, so minus 3 the whole square is plus 9, 3 into 3 9, so plus 9 I'll get, so 16 into 16, 6 6 are 36, 6 1 are 6 7 8 9, so 1 6 are 6, 1 1 are 1, 6 9 15, then 2 56, so 2 56. So this is equal to 256 plus 9 is 265. 265 I will get. So 265, if I factorize it, 5 5 5 is 25, 5 3 is 15. So I can write as a square root of 5 into 53. So 53 is a prime number, we can't further divide it. So now if you check, see if the points are collinear, then the greatest side will be equal to the sum of the other two sides. That means which is the greatest side here? So out of these three, PR is the greatest side. Okay, PQ is root 5, QR is root 212, and PR is root 265. So PR is the greatest side. So if the points are collinear, then PQ plus QR should be equal to PR, but we can see that PR is not equal to PQ plus QR. Okay, PR is square root of 265. Okay, and PQ is root 5, and QR is root 212. Okay, plus 212. So this is not equal. Okay, that's why we conclude that these 3 points are not collinear. Therefore the given points are not collinear. So if the points are collinear, then the length of the greatest side will be equal to the sum of the other two sides. Here that condition it is not satisfying, therefore it's not collinear. So here if I further simplify, QR I can write as, I can take this 2 outside, so 2 root 53 I can write. Okay, and this one PR I can write as root 5 into root 53. Now you can check root 5 into root 53 will be not equal to root 5 plus root 212 is 2 root 53. So these are not equal. That's why we conclude that the given points are not collinear. Exercise 7.1, question number 4. Check whether the points 5 comma minus 2, 6 comma 4 and 7 comma minus 2 are the vertices of an triangle. So here I'll take let P be 5 comma minus 2 and Q be 6 comma 4 and R be 7 comma minus 2. Okay, what I'll do is I'll find the distance of PQ, QR and PR. So distance of PQ, so you need to write the formula. What is the distance formula? Distance formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So here PQ is equal to 6 minus 5 square root of 6 minus 5 the whole square plus y2 minus y1, that is 4 minus of minus 2 the whole square. So this is equal to 6 minus 5 is 1 square plus 4 minus of minus 2 is plus 2. So I'll get 4 plus 2, okay, the whole square. So here 1 square is 1, so here 4 plus 1 is 6, 6 square is 36. So I'll write one more steps. So this is equal to 1 plus 36, so I'll get square root of 37. PQ is square root of 37. I'll find QR now. QR is equal to square root of x2 minus x1 the whole square, that is 7 minus 6 the whole square plus of y2 minus y1 the whole square, that is minus 2 minus of 4 the whole square. So here square root of 7 minus 6 is 1 square plus minus 2 minus 4 is minus 6 the whole square. So 1 square is 1 only. So minus 6 the whole square, minus 6 into minus 6, minus 6 into minus 6 is 36, minus 2 minus is plus. So I'll get plus 36. So again I'll get this is 37. Sorry, here PQ is square root of 37. Okay, then what is PR? PR is equal to square root of x2 minus x1 the whole square, that is 7 minus 5 the whole square plus y2 minus y1 the whole square. So y2 I have taken minus 2 minus of minus 2, okay, the whole square. Like this I'll get, okay, between P and R x1 is x1 y1 is 5 and minus 2, and for R y2 x2 y2 is 7 and minus 2. So this is equal to 7 minus 5 is 2 to the whole square plus minus 2 minus 2. So here minus into minus is plus, I'll get plus 2 the whole square. So minus 2 plus 2, that becomes 0. So this is 2 square is 4. So minus 2 plus 2 is 0, 0 square. So I'll get square root of 4 is equal to 2. So you can see PQ is equal to QR. Therefore PQR is an isosceles triangle. In an isosceles triangle, two sides, the length of two sides will be equal. So therefore PQR form an isosceles triangle. Isosceles triangle. Exercise 7.1, question number 5. The given question is, in a classroom, 4 friends are seated at points A, B, C and D as shown in figure 7.8. Champa and Chameli walk into the class, and after observing for a few minutes, Champa asks Chameli, do you think ABCD is a square? Chameli disagrees. Using distance formula, which of them is correct? See, 4 friends are sitting at places A, B, C and D. So we should check whether ABCD is a square or not. How do you find? If we should find the distance between AB, BC, CD and DA. If the distances are equal, and also we should check the diagonals. If the sides are equal and if the diagonals are also equal, then ABCD is a square. Okay, first we'll take let A. Okay, A is 3, 4, B is 6, 7 and C is 9, 4 and D is 6, 1. So we'll find the length of AB now. So AB. So what is the formula? Distance formula is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So applying here, so length AB is equal to x2 minus x1 the whole x2 minus x1 the whole square, that is 6 minus 3 the whole square plus y2 minus y1 the whole square, that is 7 minus 4 the whole square. So 6 minus 3 is 3 square plus 7 minus 4 is 3. So 3 square is 9. Again another 3 square 9. So square root of 18 I'll get. AB. What is BC? BC is equal to now square root of x2 minus x1 the whole square, that is 9 minus 6 the whole square plus y2 minus y1 the whole square, that is 4 minus 7 the whole square. So this is equal to square root of 9 minus 6 is 3 square plus 4 minus 7 is minus 3 the whole square. So this becomes 3 square is 9 and here plus minus 3 the whole square is minus 3 into minus 3 is plus 9. 3 into 3 9. So I'll get square root of 18. Now what is CD? CD is equal to AB, BC, CD. Okay, CD is x2 minus x1 the whole square, that is 6 minus 9 the whole square plus y2 minus y1 the whole square, that is 1 minus 4 the whole square. This is equal to square root of, so 6 minus 9 is minus 3 the whole square plus 1 minus 4 is minus 3 the whole square. So this is equal to minus 3 the whole square is minus 3 into minus 3 will get plus 9, and again here minus 3 the whole square, again will get plus 9. So this is equal to square root of 18. So what is now DA? DA is equal to square root of x2 minus x1 the whole square, that is 6 minus 3 the whole square plus y2 minus y1 the whole square, 1 minus 4. Sorry, DA is 6 minus, okay, then 1 minus 4, okay, all are correct only. So this is equal to 3 the whole square plus minus 3 the whole square. So I'll get 9 9. So minus 3 the whole square is plus 9. Minus 3 into minus 3 is plus 9. So square root of 18. So we have seen, we see that now AB is equal to BC is equal to CD is equal to DA. So not only this, we should check the diagonal. We will check AC. What is the length of AC? So here length of AC is equal to x2 minus x1 the whole square. Square root of x2 minus x1 the whole square, that is 9 minus 3. 9 minus 3 the whole square plus y2 minus y1 the whole square, that is 4 minus 0. 4 minus 0 the whole square. This is equal to 9 minus 3 is 6. 6 square plus 0 square. So 6 square is 36 plus 0. So I'll get 36. Square root of 36 is equal to 6. Now what is CD? Not CD. AC I found. Next BD I should the diagonal BD I should check. So diagonal BD is equal to square root of x2 minus x1 the whole square, that is 6 minus 6 the whole square plus y2 minus y1 the whole square, that is 1 minus 7 the whole square is equal to 6 minus 6 is 0. 0 square plus 1 minus 7 is minus 6 the whole square. So 0 plus minus 6 the whole square is plus 36. So 6 6 are 36, minus into minus is plus. So this is equal to 36 6. Now AC is equal to BD. So all sides are equal and diagonals are also equal. Therefore ABCD is a square. Exercise 7.1, question number 6. Name the type of quadrilateral formed in any by the following points and give reasons for your answer. So given points are minus 1, minus 2, 1 comma 0, minus 1 comma 2, minus 3 comma 0. So I'll take as these points as A, B, C, D. So what type of quadrilateral? It may be square or rectangle, or it could be parallelogram, or it could be rhombus. So how will I find it? So if the points are like this, A, B, C, D, I'll check the length of AB, BC and CD and AD. If they, and also I'll check the diagonals. Then I'll come to know whether it is square or a rhombus or a parallelogram or a rectangle. So first I'll check what is the length of AB. So AB is given by, so what is the formula? Distance formula. I'll write the distance formula. Distance formula is x2 minus x1 the whole square plus y2 minus y1 the whole square. So now what is AB? AB is square root of, so 1 x2 minus x1 the whole square, that is 1 minus 1 the whole square plus y2 minus y1 the whole square, that is 0 minus of minus 2 the whole square. So this is equal to square root of 1. So minus of minus 1 is plus 1. So plus 1 the whole square plus here 0 minus of minus 2 is plus 2. So plus 2 the whole square. So I'll get 2 square plus 2 square. So 2 square plus 2 square is 4. So I'll get square root of 8 as the answer. Now BC, what is BC? BC is equal to square root of x2 minus x1 the whole square, that is minus 1 the whole square plus y2 minus y1 the whole square, that is 2 minus 0 the whole square. So this is equal to square root of minus 1 is minus 2 the whole square plus 2 minus 0 is 2 the whole square. So this is equal to minus 2 the whole square is plus, minus 2 into minus 2 is plus 4. So plus 4 plus 2 square is 4. So I'll get square root of 8. Now what is CD? CD is equal to square root of x2 minus x1 the whole square, that is minus 3 minus of minus 1 the whole square plus y2 minus y1 the whole square, that is 0 minus 2 the whole square. So here I'll get minus 3 minus of minus 1, I'll get minus 3 plus 1 the whole square, plus 0 minus 2 is minus 2 only, minus 2 the whole square. So this I'll get minus 3 plus 1 is minus 2 the whole square, plus minus 2 the whole square is plus 4. Now again minus 2 the whole square is plus 4, plus 4 plus 4 is plus 8. So now what is dA? dA is given by square root of minus x2 minus x1 the whole square, that is minus 3 minus of minus 1, okay, the whole square, plus y2 minus y1 the whole square, that is 0 minus of minus 2 the whole square. So I'll get the square root of, so minus 3 plus 1 the whole square, plus minus of minus 2 is plus 2 the whole square. So this I'll get minus 3 plus 1 is minus 2 the whole square, plus 2 square is 4. So minus 2 the whole square is plus 4, plus 4 plus 4 is plus 8, square root of 8 I'll get. So you can check that AB is equal to BC is equal to CD is equal to DA, all are coming to be root 8. Now what is AC? AC will be the diagonal. So AC is equal to square root of x2 minus x1 the whole square, that is minus 1 minus of minus 1 the whole square, plus y2 minus y1 the whole square, that is 2 minus of minus 2 the whole square. So I'll get minus 1 minus into minus 1 is plus 1, okay, the whole square, plus 2, okay, this is like this. So 2 minus into minus is plus 2 the whole square. So here in the first term minus 1 plus 1 is 0, so 0 square, plus 2 plus 2 is 4 square. So I'll get square root of 4 square is 16, square root of 16, this is equal to 4 I'll get. Now what is BD? BD is equal to square root of, BD is the diagonal. So here my x2 minus x1 the whole square, that is minus 3 minus of 1 the whole square, plus y2 minus y1 the whole square, that is 0 minus 0 the whole square. So minus 3 minus 1 is minus 4 the whole square, plus 0 square. So minus 4 the whole square is plus 16 I'll get. Minus 4 into minus 4 is plus 16, plus 0. So root of 16 is 4. So we can check that AB is equal to BC is equal to CD is equal to DA, and AC is equal to BD. AC is equal to BD. Okay, therefore ABCD is a square. Exercise 7.1, question number 6. Sub question is 2. Points are minus 3, 5, 3, 1, 0, 3, minus 1, 4. So I'll take this as ABCD. This points as ABCD. So distance formula is given by square root of x2 minus x1 the whole square, plus y2 minus y1 the whole square. Therefore length of AB is given by square root of x2 minus x1 the whole square, that is 3 minus of minus 3 the whole square, plus y2 minus y1 the whole square, that is 1 minus 5 the whole square. So this is equal to 3 minus of minus 3 is plus 3. So 3 plus 3 I'll get the whole square, plus 1 minus 5 is minus 4 I'll get, minus 4 the whole square. So this is equal to 3 plus 3 is 6 square. So minus 4 the whole square is minus 4 into minus 4 is plus 16. Okay, so this is equal to square root of 6 square is 6 6 are 36 36 plus 16. So I'll get square root of 52. Square root of 52. 36 plus 16 is 52. Now what is BC? BC is given by square root of x2 minus x1 the whole square, that is 0 minus 3 the whole square, plus y2 minus y1 the whole square, that is 3 minus 1 the whole square. So this is equal to, so 0 minus 3 is minus 3 only, so minus 3 the whole square, plus 3 minus 1 is 2 the whole square, this is equal to, so minus 3 the whole square is plus 9, minus 3 into minus 3 is plus 9, plus 2 square is 4, so 9 plus 4 is 13, so this is root 13. So what is CD? CD is given by square root of minus x2 minus x1 the whole square, that is minus 1 minus 0 the whole square, plus y2 minus y1 the whole square, that is minus 4 minus 3 the whole square. So this is equal to, so minus 1 minus 0 is minus 1 only, so whole square, plus, so minus 4 minus 3 is minus 7 the whole square. So this is equal to, minus 1 the whole square is plus 1, minus 1 into minus 1 is plus 1, plus 7 square is 7, minus 7 into minus 7 is plus 49. So I'll get as square root of 50. What is dA? dA is equal to, now square root of minus 1 minus of minus 3, minus 1 minus of minus 3 the whole square, plus minus 4 minus 5 the whole square. So this is equal to square root of, so minus 1 minus of minus 3 is plus 3, minus 1 plus 3 the whole square, so minus 4 minus 5 is minus 9, plus minus 9 the whole square. So this is equal to, now minus 3 plus minus 1 plus 3 is plus 2 the whole square. So here plus minus 9 the whole square is 9 9s are 81. So this is equal to 2 square is 4 plus 81. So square root of 85 is the answer. Now in this question none of the sides are equal. Now let me check what is the diagonal. So I'll take AC. AC is equal to, now square root of x2 minus x1 the whole square, that is 0 minus of minus 3 the whole square, plus y2 minus y1 the whole square, that is 3 minus 5 the whole square. So I'll get so 0 minus of minus 3 is plus 3 the whole square, plus 3 minus 5 is minus 2 the whole square. So here I'll get 0 plus 3 is 3 only, 3 square. So plus minus 2 the whole square is minus 2 into minus 2 is minus 4, sorry, plus 4. So I'll get 9, 3 square is 9 plus 4. So I'll get square root of 13. And what is BD? BD is equal to square root of x2 minus x1 the whole square, that is minus 1 minus 3 the whole square, plus y2 minus y1, that is minus 4 minus 4 minus 1 the whole square. So this is equal to, so minus 1 minus 3 is minus 4 the whole square, plus minus 4 minus 1 is minus 5 the whole square. So this I'll get minus 4 the whole square is 16, minus 4 into minus 4 is plus 16, plus minus 5 the whole square is minus 5 into minus 5 is plus 25. So 16 plus 25, 20, 30, 40, 41. I'll get square root of 41. So in this question there is one important thing that should be noted. See, AB is square root of 52. Okay, so 52 I can factorize. I can write it as 2 into 2 into 13. 2 to the 4, 4 into 13 is 52. So here 2 I can take outside. I'll get 2 root 13. So AB I'll write as 2 root 13. Now you can see that AB is equal to 2 root 13, which is also equal to BC plus AC. So what is BC? BC it is given as root 13, and AC also we got it is root 13. So root 13 plus root 13 is 2 root 13. So it means, therefore ACB lie on a same line. That means the given the points are like this. This is A, this is point B, and this is point C. Okay, it's like this. They are like in the same line, and D is somewhere here. So it's like this. So since ACB are lying on a straight line, the given points are not the coordinates of a quadrilateral. In fact, it's a triangle. ADB makes a triangle, and C is a point on line AB. Therefore ABCD is not a quadrilateral. I'll show this in graph. See, this is how it looks in the graph. Point A is minus 3 comma 5, point B is 3 comma 1, and point C is 0 comma 3, and point D is minus 1 comma 4. So if I join the points, it is like this. And point C, it is actually lying on line AB. That's why the length of AB is equal to AC plus CB. Therefore the given coordinates are not the points of a quadrilateral. So this, just for your understanding, I am showing this graph, and that ends this problem. Exercise 7.1, question number 3. Sub question 3, the given coordinates are 4 comma 5, and then 7 comma 6, and then 4 comma 3, and 1 comma 2. So I'll take this as A, B, C, and D. So what is the distance formula? Distance formula is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So now length of AB is equal to square root of 7 minus 4 the whole square plus 6 minus 5 the whole square. So this is equal to 7 minus 4 is 3. So square root of 3 square plus 6 minus 5 is 1 square. So this is equal to 3 3s are 9 plus 1 square is 1. So I'll get square root of 10. Now what is BC? BC is equal to square root of x2 minus x1 the whole square, that is 4 minus 7 the whole square plus y2 minus y1 the whole square, that is 3 minus 6 the whole square. So this is equal to, now 4 minus 7 is minus 3. So minus 3 the whole square plus 6 minus 3 minus 6 is minus 3 the whole square. So this is equal to minus 3 the whole square is minus 3 into minus 3 is plus 9. So plus, so here minus 3 the whole square, again I'll get 9. So this I'll get square root of 18. Now what is CD? CD is given by square root of x2 minus x1 the whole square, that is 1 minus 4 the whole square, plus y2 minus y1 the whole square, that is 2 minus 3 the whole square. Now this is equal to 1 minus 4 is minus 3 the whole square, plus 2 minus 3 is minus 1 the whole square. So this is equal to minus 3 the whole square is minus 3 into minus 3 is plus 9, plus 1 square minus 1 the whole square is minus 1 into minus 1 is plus 1. So I'll get square root of 10. Now what is dA? dA is equal to square root of x2 minus x1 y2 minus x2 minus x1 the whole square, that is 1 minus 4 the whole square, plus y2 minus y1 the whole square, that is 2 minus 5 the whole square. So I'll get square root of 1 minus 4 is minus 3 the whole square, plus 2 minus 5 is minus 3 the whole square. So minus 3 the whole square is plus 9, and again minus 3 the whole square is plus 9. So 9 plus 9 18. So square root of 18 I'll get. Now I'll check what is AC. So AC is equal to square root of, in this problem before checking the diagonal only I cannot decide what type of quadrilateral is this. Now AB I got 10, and BC I got a square root of 18. So this is something like this: A B C D. So AB is root of 10, BC is 18, and CD is root of 10, and AD I got root of 18. So it's a parallelogram. So there's no need to check the length of AC and DB. So without checking the length of the diagonal, we can safely conclude that it's a parallelogram. But anyway, we'll check it. What is AC? AC is given by 4 minus 4 the whole square, plus y2 minus y1 the whole square, that is 3 minus 5 the whole square. So 4 minus 4 is 0 square, plus 3 minus 5 is minus 2 the whole square. So this is equal to 0 square is 0 only, plus minus 2 the whole square is minus 2 into minus 2 is plus 4. So this is square root of 4, that is 2 I'll get. And what is BD? BD is equal to x2 minus x1 the whole square, that is 1 minus 4 the whole square, plus y2 minus y1 the whole square, that is 2 minus 5. Okay, 2 minus 5 the whole square. So this is equal to 1 minus 4 is minus 3 the whole square, plus 2 minus 5 is again it's minus 3 the whole square. So minus 3 the whole square is plus 9. Again minus 3 the whole square is plus 9. So I'll get 9 plus 9 18. So BD I'm getting root 18. Oh, BD can't be square root of 18. I have made some mistake. So here 1 minus 7. So it's wrong here. So this is square root of 1 minus 7. 1 minus 7 the whole square, plus this is 2 minus 6 the whole square. So this is equal to minus 6 the whole square plus minus 4 the whole square. So I'll get 36 square plus 4 4s are 16. Sorry, 36 plus 16 I'll get. So 36 plus 16 is square root of 52. So BD is square root of 52. So it was not necessary to find AC and BD, but still we found just by looking at the length of AB, BC, CD and DA. We could have concluded that this is a parallelogram. So A, B, C, D is a parallelogram. Exercise 7.1, question number 7. So question number 7 says, find the point on the x-axis which is equidistant from 2, 5 and minus 2, 9. Okay, I'll take A as 2, minus 5, and I'll take B as minus 2, 9. Now we should find a point which is equidistant from point A and point B. Okay, let P be the point which is equidistant from A and B. Okay, now since P lies on x-axis, so it's given find the point on the x-axis which is equidistant. Okay, so since P lies on x-axis, the y coordinates will be 0. Y coordinate will be 0. That means P of x, 0 is the coordinate of P. Now what is AP? Now AP is given by, that is the distance between the point A and P. What is the distance formula? Distance formula is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Therefore the distance between AP is given by x2 minus x1 the whole square, that is I'll take x2 y2 as 2 and minus 5. So 2 minus x the whole square plus minus 5 minus 0 the whole square. So this is equal to 2 minus x the whole square plus minus 5 minus 0 is minus 5 only, minus 5. Okay, now this again this I can write as 2 minus x the whole square. So minus 5 into minus 5 is 25 plus 25 I will get. I'll mark this as question 1. Now what is BP? BP is given by square root of distance between point P and B. Now x2 minus x1 the whole square, that is minus 2 minus of x the whole square plus y2 minus y1 the whole square, that is 9 minus 0 the whole square. So here I will get square root of minus 2 minus x the whole square plus 9 minus 0 is 9 only, 9 square I will get. So here I will get square root of minus 2 minus x the whole square plus 9 nines are 81 I will get. This I will mark as 2. Now given that P is equidistant from point A and point B, therefore AP is equal to BP. So I will equate 1 and 2. Therefore I will equate 1 and 2. That means square root of 2 minus x the whole square plus 25 is equal to square root of minus 2 minus x plus the whole square plus 81. So 1 is equal to 2. Now I'll square both the sides. Squaring both sides I will get square root of 2 minus x the whole square plus 25 the whole square is equal to square root of minus 2 minus x the whole square plus 81 the whole square. So when I square, the root symbol will get eliminated, so I'll be left with 2 minus x the whole square plus 25 is equal to minus 2 minus x the whole square plus 81. The square root symbol and the power of 2 here will get eliminated. Now the left hand is 2 minus x the whole square plus 25. So in the right hand side I'll make one simplification here. I'll take minus 1 common factor. Minus 1, if I take common factor, it becomes 2 plus x, okay, the whole square. If I open the bracket, it will become the original only. Okay, just simplification I have done. So plus 81. Now 2 minus x the whole square plus 25 is equal to, now this one I can write as minus 1 the whole square into 2 plus x the whole square plus 81. Now the right hand side, minus 1 the whole square is 1 only, so 1 into 2 plus x the whole square plus 81. So 1 into 2 plus x the whole square is 2 plus x the whole square only plus 81. Now I'll use formula a plus b the whole square is equal to a square plus b square plus 2ab. Also a minus b the whole square is equal to a square minus b square minus 2ab. I'll use this formula and expand the both left hand side and the right hand side also. So in the left hand side is 2 minus x the whole square plus 25. So now I'll use the formula and expand 2 minus x the whole square. So this becomes 2 square plus x square minus 2 into ab minus 2 into x plus 25. So in the right hand side, 2 square, I am expanding 2 plus x the whole square. So 2 square plus x square plus 2 into a into b, 2 into x plus 81 I will get. So in the left hand side I will get 4 plus x square minus 2 into x is 4x minus 4x plus 25. The right hand side 4 plus x square, so plus 2 into 2 is 4x, 2 into 2 into x, 4x plus 81. So 4 I'll get, I can cancel, and x term also I can cancel, x square I can cancel. So I am left with minus 4x plus 25 is equal to plus 4x plus 81. I'll bring 4x to the right hand side and bring this 81 to the left hand side. So I'm left with 25 minus 81 is equal to 4x plus 4x. If I bring minus 4x to the right hand side, it becomes plus 4x. So 25 minus 81, so how much? So subtraction, 10, 11 minus 5 is 6, 7 minus 2 is 5. So sign is minus. So minus 56 is equal to 8x, or minus 56 by 8 is equal to x. So 8 ones are 8, 8 sevens are 56. So minus 7 is equal to x. X is equal to minus 7. Therefore, what is the coordinates of P? It is x comma 0. Therefore, the coordinates of P is x comma 0, that is minus 7 comma 0. So P lies on x axis, therefore y coordinates will be 0. Exercise 7.1, question number 8. Find the value of y for which the distance between the points P of 2, minus 3 and Q of 10, y is 10 units. So P is given as 2, minus 3 and Q is 10, y. So PQ is given as 10. So the distance between P and Q is 10, and find the y coordinate of Q. That's the question. So distance formula is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So PQ is equal to 10, which is given by square root of x2 minus x1 the whole square, that is 10 minus 2 the whole square plus y2 minus y1 the whole square, that is y minus of minus 3 the whole square. Okay, like this. So now I'll square both the sides. Square both sides. When I square both the sides, I'll get 10 square is equal to square of 10 minus 2 the whole square plus y minus into minus is plus y plus 3. I'll get y plus 3 the whole square. So this I'll square. So here on in the left hand side, 10 square is 10 into 10, that is 100. So this is equal to, here this square root and this power of 2 will get cancelled. I will be left with 10 minus 2 the whole square plus y plus 3 the whole square I will get. So here 100 is equal to 10 minus 2 is 8. So 8 square plus y plus 3 the whole square. I will bring this side. So 8 square is 64. So 100 minus 64 is equal to y plus 3 the whole square. So 100 minus 64 is 36. I will get 36 is equal to y plus 3 the whole square. Now I will taking square root of both the side. Square root on both sides. So I'll get square root of 36 is equal to y plus 3 the whole square. So in the left hand side, square root of 36 is plus or minus 6. Okay. Now in the right hand side, the square root and power of 2 will get cancelled. I will be left with y plus 3. So it means plus 6 is equal to y plus 3 or minus 6 is equal to y plus 3. So here I will get, if I bring 3 to the left hand side, 6 minus 3 is equal to y is equal to 3. So also minus 6 is equal to y plus 3. If I bring minus 3 to the left hand side, minus 6 minus 3 is equal to y. So minus 9 is equal to y. So y is equal to plus 3 or y is equal to minus 9 is the answer. The next question in exercise 7.1 is question number 9. So the question is, if q of 0, 1 is equidistant from p of 5 minus 3 and r of x minus 6, find the value of x. Find also the distance qr and qp. So given in the question, q is 0, 1 and p is 5, minus 3 and r is equal to x, 6. So we should find the value of x such that qp is equal to qr. So qp is equal to qr, right? So distance formula, what is distance formula? Distance formula is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now qp is equal to qr. So what is qp? Qp is given by square root of 0 minus 5 x2 minus x1 the whole square plus y2 minus y1 the whole square, that is 1 minus of minus 3 the whole square. So this is equal to, what is qr? Qr is given by x2 minus x1 the whole square, that is 0 minus x the whole square plus 1 y2 minus y1 the whole square, that is 1 minus 6 the whole square. So here I will get 0 minus 5 is minus 5 only, minus 5 the whole square plus here 1 minus into minus of minus 3 is plus 3, minus into minus I will get plus the whole square. Square root of this is equal to, here 0 minus x is x only, 0 minus x is minus x the whole square plus 1 minus 6 is minus 5 the whole square square root of this. Now I'll get minus 5 into minus 5 is plus 25. I'll get plus 25 plus 1 plus 3 is 4. 4 square root of this is equal to minus x, the whole square is x into x, minus x into minus x is minus x square, sorry, plus x square, minus x the whole square is plus x square. So x square plus minus 5 into minus 5 is plus 25. So now I'll square both the sides, square both sides. So I'll get square root of 25 plus 4 square, the whole square is equal to x square plus 25, the whole square. So square root symbol and this power of 2 will get cancelled. I'll be left with 25 plus, so 4 square is 16 is equal to x square plus 25 I'll get. So squaring both sides, right? Okay. Now it's correct. So now 25 will get cancelled. X square is equal to 16. X square is equal to 16, or x is equal to square root of 16. So or x is equal to plus or minus 4. Now x is equal to plus or minus 4. Now we should find the distance QR and PR. Okay. First, for x is equal to plus 4, I'll find, what will I find? QR. So QR is equal to, QR is given by square root of, so Q is 0 minus 0 1 and R is plus 4 comma 6. So QR is equal to 0 minus x. So x is plus 4, I am taking now, the whole square, plus 1 minus 6, the whole square. So this is equal to minus 0 minus 4 is minus 4, minus 4 the whole square, plus this 1 minus 6 is minus 5 the whole square. So I'll get minus 4 the whole square is minus 4 into minus 4 is plus 16, plus, so 5 square minus 5 the whole square is plus 25. So 16 plus 25 is 20, 30, 36, 41. I'll get 41. And what is QR? Now what is PR? PR is given by square root of 0 minus 4 the whole square plus PR. Okay, P, I am taking P, right? So this is 5. Okay, 5 minus 4 the whole square plus minus 3 minus 6 the whole square. So I'll get 5 minus 4 is 1 square. So this is minus 3 minus 6 is minus 9 plus of minus 9 the whole square. So this is equal to square root of 1 square root of 1 square is 1 only, plus minus 9 the whole square is 9 9s are 18, sorry, 9 9s are 81. So I'll get square root of 82 as the answer. This is for x is equal to 4. Now but for x is equal to minus 4, what is the value of QR? For x is equal to minus 4, QR is equal to square root of QR. So 0 minus x, so minus of minus 4 the whole square, plus y2 minus y1, that is 1 minus 6 the whole square. So here I'll get 0 minus of minus 4 is plus 4 the whole square, plus minus 5 the whole square. So here 0 plus 4 is 4 only. So 4 square is 16, plus minus 5 the whole square is plus 25. So sum of these two is 41. Now for what is the value of PR? What is the value of PR? PR is given by square root of P and R. So this is x2 minus x1, that is 5 minus x, now it is minus 4, x1 is minus 4, minus of minus 4 the whole square plus y2 minus y1 the whole square, that is minus 3, minus of minus 3 minus 6 the whole square. So this is 5 minus into minus is plus, 5 plus 4 I will get 5 plus 4 the whole square plus minus 3 minus 6 is minus 9 the whole square. So 5 plus 4 9, so 9 square. So here plus minus 9 the whole square is 81. Minus 9 into minus 9 is plus 81. So again I will get 81 plus 81. Now here I will take 81 into 81 I can take as 2 into 81. Now square this, again I can write as root 2 into root 81. So square root of 81 is 9 9s are 81, so it becomes 9 into root 2. So for x is equal to 4 I get QR root of 41 and PR is equal to root of 82. For x is equal to minus 4 I will get QR is equal to square root of 41 and PR is equal to 9 root 2. Exercise 7.1, question number 10. Find a relation between x and y such that the point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. So let A be x comma y I will take, and I will take B to be 3 comma 6 and I will take C as minus 3 comma 4. Okay. Now point A is x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. That means AB should be equal to AC. So what is AB? What is the, first of all, what is the distance formula? Distance formula is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So now what is AB? AB is square root of x2 minus x1 the whole square, that is x minus 3 the whole square plus y2 minus y1 the whole square, that is y minus 6 the whole square. So this is equal to AC. AC is given by x minus of minus 3 the whole square plus y minus 4 the whole square. So now I will square both the sides. Okay, squaring both sides, if I square I will get rid of the square root symbol. So when I square this, first let me write the equation as it is: x minus 3 the whole square plus y minus 6 the whole square is equal to, so here x minus of minus 3 is plus 3 I will get, so this whole square plus y minus 4 the whole square. So squaring both the sides means I am squaring like this. Okay, when I square, the square root symbol will go, so ultimately I will be left with x minus 3 the whole square plus y minus 6 the whole square is equal to x plus 3 the whole square plus y minus 4 the whole square. Now I'll expand using the formula. Okay, a plus b the whole square is given by a square plus b square plus 2ab, and a minus b the whole square is given by a square plus b square minus 2ab. So x minus 3 the whole square is, so x square plus 3 square minus 2 into x into 3 plus y minus 6 the whole square is y square plus 6 square minus 2 into y into 6. So this is equal to, in the right hand side, what is there, x plus 3 the whole square, that is x square plus 3 square plus 2 into 2ab 2 into x into 3 plus y minus 4 the whole square is y square plus 4 square minus 2 into y into 4. Okay, now in the left hand side and the right hand side x square is common. I can cancel 3 square, so y square also I can cancel. Now I am left with minus 2 3s are 6 minus 6x in the left hand side minus 2 6 are 18y is equal to, in the right hand side 2 3s are 6x minus 2 4s are 8y. Also I am left with 4 square, so 4 square 16. So in the left hand side one more term I have left, that is how much, 6 square I have left it, so 6 square also I am writing. So now I will bring all the x term to the left hand side, minus 6x minus 6x, so everything I will bring to the left hand side, minus 6x, then minus 18y, so I will bring this minus 8y also, it becomes plus 8y. So now 6 square is 36 plus 36, 6 6 are 36, and I will bring this 16 also to the left hand side, it becomes minus 16. So minus 6 is minus 12x. So here plus 8y, sorry, minus 8y plus 8y is, I will get minus 18 minus 8 is 10y I will get. So this is equal to 0. Now 36 minus 10 is 20. 36 minus 16 is 20 I will get, is equal to 0. So here one small mistake I have made. So in the left hand side I will get minus 12y, this is 12y. So this is 12y. So minus 12y plus 8y is, I will get 4y. Okay, minus 4y I will get. So now I will divide throughout by 5. When I divide by 5, sorry, I will divide by 4. So I will get minus 4 3s are 3x minus 3x minus y plus 5 is equal to 0 I will get. So how to do that division? So minus 12x minus 4y plus 20 is equal to 0. Dividing by 4 means it is like this. So here I can divide, I should divide all the terms, that is minus 12 by x by 4 minus 4x by 4 plus 20 by 4 is equal to 0 by 4. 0 by 4 is 0 only. So 4 1s are 4, 4 3s are 12. minus 3x minus minus y, sorry, this is y, minus y, 4 on the 4, 4 on the 4, here 4 on the 4, 4 5 the 20. I'll get like this. Now if I multiply by, if I multiply by minus 1, I'll get 3x plus y minus 5 is equal to 0. So this is the relation between x and y, for which the point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. And that completes this problem and this exercise. In this problem you can end here itself, at this point itself, or you can end at this point, or you can end at this point. So whatever it is, still it will be right only, you will get full marks. The last two types is just a simplification, that's it. Otherwise you can end in the first case itself, where it is minus 12x minus 4x plus 20 is equal to 0. The next topic is section formula. So in the textbook you can see there's one diagram given here, same thing I've drawn here. Now here you can see there's a xy plane, this is the origin. AB are 2 points, and coordinates of A is x1 y1 and coordinates of B are x2 y2, and P is a point, P of x comma y is a point which lies on the line AB. Okay, and P divides the line AB in the ratio m1 is to m2. So AP by PB is m1 by m2. In that way P is lying on AB. Now what I am doing is, from A I will draw one perpendicular to x-axis, that is it meets at R, and again from P I will draw one perpendicular to x-axis, and from B also I will draw one perpendicular to x-axis, and also from A I will draw one perpendicular to PS, and from P I will draw one perpendicular to BC. Okay, now you can see in the diagram there are two triangles, triangle AQP and triangle PCB. Okay, both these two triangles are similar to one another. What's the reason? Reason is simple, because of AA criteria. AA criteria of similarity of triangles. Which are the two angles that are similar? AA means angle. See, angle A is equal to angle P. Okay, angle A is equal to angle P. Why? Because AQ is parallel to PC. Therefore, angle A is equal to angle P. These two are corresponding angles. And angle Q is 90 degree. Angle C is also 90 degree. So I am writing angle Q is equal to angle C is equal to 90 degree. So since two angles are equal, if two angles of a triangle is equal to the corresponding two angles of another triangle, then those two triangles are similar to one another. Okay, so if triangles are similar, then their sides will be proportional, isn't it? Now what are the sides? AP by PB, AP by PB will be equal to AQ by PC will be equal to PQ by BC. Okay, now what is the length of AP? AP is nothing but M. AP by PB is M1 by M2, because P divides AB in the ratio M1 is to M2. And what is the length of AQ? AQ is nothing but X minus X1. And what is the length of PC? Length of PC is X2 minus X1. Sorry, X2 minus X. And what is the length of PQ? Length of PQ is Y minus Y1. You can check in the diagram. And what is the length of BC? Length of BC is y2 minus y. Now I'll take only these two and I'll cross multiply. Okay, if I cross multiply, m1 into x2 minus x is equal to m2 into x minus x1. Now I will open the bracket. M1 x2 minus m1 x is equal to m2 x minus m2 x1 I will get. Now I will solve for x. Bring all the x term one side, okay, and x and the remaining term to the other side, okay, like this I'll do. So now m1 x2 plus m2 x1 is equal to m2 x plus m1 x I'll get. Now here on the right hand side I can take x as common factor, x into m1 plus m2, okay, here m1 x2 plus m2 x1. So if I solve for x now, what will be x? X is equal to m1 x2 plus m2 x1 divided by m1 plus m2 will be the value of x. Now similarly again I will consider this and this, okay, that means m1 by m2 is equal to y1 minus y1, y minus y1 by y2 minus y. Now I'll cross multiply. If I cross multiply, m1 into y2 minus y is equal to m2 into y minus y1 I'll get. I'll open the bracket. m1 y2 minus m1 y is equal to, here also I'll open the bracket, m2 y minus m2 y1. So now y term I'll bring to the right hand side, okay, and this I'll bring to the left hand side. So I'll get m1 y2 minus, sorry, plus m2 y1 is equal to m2 y plus m1 y I'll get. Now m1 y2 plus m2 y1 is equal to, here I'll take y common factor, y into m1 plus m2 I'll get. Now if I solve for y, I'll get y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. So this is nothing but x and y are nothing but the coordinate of P, okay. Therefore I am writing coordinates of x and y is equal to m1 x2 plus m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. This is the coordinates of x comma p of x comma y. So this is also called section formula. So you can check in the textbook, they have derived section formula, this one. So same thing I've explained. Whichever method you find easy, you can study in textbook method or whatever I have taught just now. And here there are some cases. So this is the section formula. Section formula is nothing but the coordinates of p of xy which lies on the point which lies on the line AB. So in this section formula, if I take m1 is equal to k and m2 is equal to 1, okay, then 1 becomes, I'll take this as 1, then 1 becomes p of x comma y is equal to, I'll substitute m1 is equal to k and m2 is equal to 1. I'll get k x2 plus x1 by m1 plus m2 and k y2 plus y1 by k plus 1. This will take us to, so now P is a point which divides the line AB in the ratio k is to 1, and in there is another case where P divides the line AB in two equal parts. That means m1 is equal to m2 is equal to 1. So if m1 is equal to m2 is equal to 1, then P of x comma y is equal to 1 into x2 plus 1 into x1 by 1 plus 1, and here 1 into y2 plus 1 into y1 by 1 plus 1 I'll get. I'm substituting m is equal to 1 and m2 is equal to m1 is equal to 1 and m2 is equal to 1 in equation 1. That's it. So here I'll get x1 plus x2 by 2 and y1 plus y2 by 2. This I'll mark as 3. So this is nothing but the midpoint formula. Okay. So here P divides the line AB in two equal parts. That means it is like this. If AB is a point, AB are 2 points, and there if we join AB, then P divides AB into two equal parts. That means AP by PB will be equal to 1. That means AP, okay, like this it is. In the first case, P of xy divides the line AB in the ratio m1 is to m2. In the second case, P divides the line AB in the ratio k is to 1, and in the third case, P divides the line AB in the ratio 1 is to 1. Now we can go through the text. There are some worked examples given. See in example 6, find the code in this one. There are 2 points, 4 comma minus 3 and 8 comma 5, and we should find a point P which divides the line joining these 2 points in the ratio 3 is to 1. So all are self-explanatory. You can go through. So here P and Q is there, and sorry, A and B is there, and P is there. So we should find the ratio m1 is to m2. What is that we should find? They are found here. All these are self-explanatory. You can go through it. And see in example 8, AB are 2 points, and on the line joining AB there are 2 points P and Q, such that AP is equal to PQ is equal to QB. We should find the coordinates of P and Q. So go through it. All are self-explanatory. Now here in this problem there are 2 points, 5 comma minus 6 and minus 1 comma 4, and the x-axis divides the line joining these 2 points. So what is that coordinate we should find? So, and here there are 4 points A, B, C, D, and they are telling that these 4 points make a parallelogram, and we should find the value of P. P is the x coordinate of point D. Go through it. All are self-explanatory. I'll be solving exercise problems. So exercise 7.2, question number 1. Find the coordinates of the point which divides the join of minus 1 comma 7 and 4 comma minus 3 in the ratio 2 is to 3. So I'll take point A as minus 1 comma 7 and point B as 4 comma 3, and let P of xy divide AB in the ratio 2 is to 3. I'll take, therefore P of xy is given by, what is the section formula? Section formula is, first write the formula, m1 x2 plus m2 x1 by m1 plus m2, and y coordinates is my2 plus m2 y1, m1 y2 plus m2 y1 divided by m1 plus m2. Now substitute the values of m1 x1 x2 y1 and y2. So m1 is 2, x2 is 4 plus m2 is 3, and x1 is minus 1 by m1 plus m2, that is 2 plus 3. So here 2 plus 3, then m1 is 2, and y2 is minus 3, and plus m2 is 3, and y1 is 7 into 7. Okay, so I'll get 2 4s are 8 and 3 1s are 3, so minus 3 I'll get. So 2 plus 3 comma 2 3s are 6, minus 6 I'll get, minus 6, 3 7s are 21 plus 21 divided by 2 plus 3. So 8 minus 3 is 5 by 5. This is minus 6 plus 21 is plus 15 I'll get by 5. So here 5 1s are 5, 5 1s are 5, 5 1s are 5, 5 3s are 15. So coordinates of P and Q is 1, 3. So if you actually plot the graph, you will get like this. A is here 1 minus 1, 7, B is somewhere here 4, minus 3, and P is 0.1, 3. P is dividing this line in the ratio 2:3. This is 2, this is 3. Okay, not necessary to draw this, just for your reference, for your idea I am giving it, and that completes this problem. Exercise 7.2, question number 2. Find the coordinates of the points of trisection of the line segment joining 4, minus 1 and minus 2, 3. So there are 2 points. 2 points are 4, minus 1, 4, minus 1, and another point is minus 2, 3. So let they be A and B. Okay, and on A and B there are 2 points P and Q. The point P and Q says that AP, length of AP is equal to length of PQ is equal to length of QB. Okay, that's the meaning of trisection. Find the coordinates of the points of trisection of the line segment joining. Okay, that means 2 points divides the given line into 3 equal parts. Now that means what will be the ratio? Now AP is to PQ is to QB is 1:1:1. Okay, now what is ratio of AP? AP is to PB. Now you can see AP by PB will be equal to 1:2. Okay, now therefore point of value of the coordinates of P is P of x, y is equal to, here m is 1 and m2 is 2. So substitute the value of m1 m2 here. Now what is the formula first? Write the formula first. M1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. So now substitute the value of m1 m2 here. M1 is 1 into x2 y2 I'll take b. Okay, so x2 is minus 2 plus m2 is 2 and x1 is 4. Okay, divided by m1 plus m2 I'll get 1 plus 2. Here m1 is 1, again y2 is minus 3 plus m2 is 2 and y1 is minus 1 divided by m1 plus m2, that is 1 plus 2. So here I'll get 1 into minus 2 is minus 2 plus 2 4s are 8 by 1 plus 2 is 3. Here denominator I'll get 3. So 1 into minus 3 is minus 3. my 2 plus 2 into minus 1 is minus 2, so minus 2. So here I'll get minus 2 plus 8 is plus 6 by 3, and minus 3 minus 2 is minus 5. Okay, minus 5 by 3. So here 3 ones are 3 twos are, so I'll get 2 comma minus 5 by 3 is the coordinates of point B. Similarly, now what is the coordinates of point Q? So Q of x comma y is given by, now here m is equal to, see now PQ is to QB will be 2:1. That means m1 will be 2 and m2 will be equal to 1. Okay, so now I'll write again here the diagram. This is A B, this is PQ, lengths are like this, ratios are like this. Now here this length by this length is, this length is 2, this length is 1, so m1 by m2 is 2:1. So m1 I'll take 2, m2 as 1. Now I'll substitute here m1 is 2. Now m1 is 2 into x2 is minus 2, then plus m2 is 1 into x1 is 4, divided by m1 plus m2 is now 2 plus 1, comma, then m1 is 2, y2 is minus 3, plus m1, now m1 is 1 and sorry m2 is 1 and y1 is minus 1, divided by 1 plus 2. So I'll get 2 into 2 minus 4 plus 1 4s are 4, divided by 2 plus 1 3, comma 2 3s are minus 2 3s are 6, so minus 6 I'll get. So 1 into minus 1 is minus 1 by 3. So minus 4 plus 4 is 0 by 3, comma, so minus 6 minus 1 is minus 7 by 3. So 0 by any number is 0 only. Therefore this is Q of x comma y is 0 comma minus 3 by 7. That completes this problem. Exercise 7.2, question number 3. To conduct sports day activities in your school rectangular shaped school ground ABCD, lines have been drawn with chalk powder at a distance of 1 meter each. So there is a school ground like this, and lines have been drawn like this, which are 1 meters apart. Okay, the distance between this line and this line is 1 meter, this line and this line is 1 meter, like that they have drawn using a chalk powder, and 100 flower pots have been placed at a distance of 1 meter from each other along AD. So this is line AD, and at each at a distance of 1 meter one pot is placed. So 100 pots are placed. That means the length of AD is 100 meters. Now Niharika runs 1/4 the distance AD on the second track. Niharika starts from second track. She covers a distance of 1/4 of AD, and she will post a flag there. And another girl, Preeti, runs and she runs 1/5 the distance of AD from 8th track, and she will post flag here. Now what is the distance between this flag and this flag? That's the question. What is the distance between both the flags? And another girl is coming here. If Rashmi has to post a blue flag exactly halfway between the line segment joining the two flags, where should she post her flag? So we should find the midpoint of these two flags, midpoint of the line joining these two flags, and in between that whatever point will come, at that point Rashmi will post a flag. And what is the midpoint of that is the question. So I have simplified and written the graph here. Now the length of AD is 100 meter because 100 pots are placed and each pot is 1 meter apart from one another. Okay, therefore AD is 100 meter. Now Niharika starts from second track and she covers one fourth of AD. Okay, so 1/4 somewhere she covers this much distance, so that is Niharika. So what is the coordinate of Niharika? It is 2 comma, so 1/4 of AD means 1 by 4 of AD is equal to 1 by 4 into AD is 100. So 4 ones are 4, 4 twos are 8, 4 fives are 20. So 1 into 25 is 25. So she is covering 25 meters of distance. So coordinate of Niharika is 2 comma 25. Now Preeti she starts she runs in track 8. So from this point she runs and she covers 150 of AD. So what is AD is 100 meters. So 1 by 5 into 100. 5 ones are 5, 5 twos are 10, 0. So 20. So she posts flag here. So this coordinate is 8 comma 20. Now I should find the distance. So this is Preeti, right? So I should find the distance of NP. So NP distance formula is given by x2 minus x1 the whole square plus y2 minus y1 the whole square. I will take x2 y2 as a p, that is, so 20 minus okay, first I'll take x only, square root of 8 minus 2 the whole square plus 20 minus 25 the whole square. So this is equal to 8 minus 2 is 6 square plus 20 minus 5 is minus 5 the whole square, square root of this. So this is 36 plus 5 5 is 25. So I'll get 36 plus 25, 30, 40, 50, 60, 61. So root 61 I'll get. Now what is the question? What is the midpoint of this one? Okay, Rashmi has to post a blue flag exactly halfway between the line segment joining the two flag. Where should she post her flag? So Rashmi, the midpoint of NP is somewhere here. So Rashmi has to post flag there. So that I'll take as R of x comma y. So what is the coordinate of R is the question. Now since R is the midpoint of NP, NR by so NR by RP will be equal to 1:1 because R is the midpoint of NP. Therefore, what is the midpoint formula? Midpoint formula is given as, so R x comma y. So midpoint formula is given by x1 plus x2 by 2 comma y1 plus y2 by 2. This is the midpoint formula. Substitute the values of x1, x2, y1 and y2 here. So x1 is 2, y1 is 8 by 2 comma y1 is 25, y2 is 20 by 2. So this is equal to 2 plus 8 is 10 by 2 comma 45 by 2. So 2 ones are 2, 2 5s are 10. So 5 comma, that one also I can divide. 2 ones are 2, 2 twos are 4, 2 twos are 4, 2 twos are 4 comma 2 5s are 10. So 22.5. So 5 comma 22.5. So Rashmi should start on track 5 and after 22.5 meters she should post the flag. So the distance given is in meter, therefore np will be equal to square root of 61 meter, and Rashmi should start from track 5 and post at a distance of 22.5 meters, at a distance of 22.5 meters. So last one more sentence I have added there. Rashmi should start on track 5 and post flag at a distance of 22.5 meters, and that completes this problem. Exercise 7.2, question number 4. Find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by -1, 6. So here there are 2 points. Let us say it's P and Q. Okay, P and Q. So point P is -3, 10 and Q is 6, -8. So and one point is lying on this line. Okay, that is, let us say I'll call it this as A, -1, 6. So what is the ratio in which the line segment joining the points? Okay, that means I should find the ratio, that is PA by AQ. I should find what is the ratio, or simply what is M1 is to M2. Okay, this is M1, this is M2. So what is the midpoint formula? Sorry, section formula. Section formula is given by A of x, y. First I'll write the formula only, that is M1 x2 plus M2 x1 by M1 plus M2, comma M1 y2 plus M2 y1 by M1 plus M2. This is the section formula. So coordinates of A is already known. So coordinate of A is -1, 6. So -1, 6 is equal to M1 we don't know. Substitute the value of x1, x2 and y1, y2 here. So x2 is -8 plus M2. X1 is -3. So M1 plus M2 plus M2, and here M1 y2 is -8. Sorry, here I have made a mistake. x2 is 6. Okay, now here M1 into y2 is -8 plus M2 we don't know, plus y1 is 10 into 10 divided by M1 plus M2. So this is equal to 6 M1 minus 3 M2 by M1 plus M2, comma this is -8 M1 plus 10 M2 divided by M1 plus M2. So now 1 is equal to this and 6 is equal to this. Okay, I'll equate that one. So -1 is equal to 6M1 minus 3M2 by M1 plus M2. I'll cross multiply. So -1 into M1 plus M2 is equal to 6M1 minus 3M2. So if I open the bracket, -1 into M1 is -M1, then -1 into plus M2 is -M2 is equal to 6M1 minus 3M2. So M1, this I'll take to the left hand side, minus M1 minus 6M1, this I'll take to the right hand side. So minus 3M2 plus M2. So minus M1 minus 6M1 is minus 7M1 I'll get. So here minus 3M2 plus M2 is minus 2M2 I'll get. So now again I'll cross multiply. I'll bring M1 to the to the left hand side. If I bring m1 to the left hand side, it will come to the denominator, and I'll take this minus 7 to the right hand side. That will also come in the denominator. So m1 by m2 is equal to minus 2 by minus 7 I'll get. So here it will get cancelled. m1 by m2 I'll get as 2:7. Now what if I equate 6 and this term? So 6 is equal to minus 8 m1 plus 10 m2 by m1 plus m2. So when I cross multiply, 6 into m1 plus m2 is equal to minus 8 m1 plus 10 m2. So if I'll open the bracket, 6 m1 plus 6 m2 is equal to minus 8 m1 plus 10 m2. So I'll bring this to the left hand side, I'll take this to the right hand side. So 6 m1 minus 8 m1 becomes plus 8 m1. So this is equal to 10 m2 plus, sorry, 6 m2. If I take to the right hand side, it becomes minus 6 m2. So 6 plus 8, 6, 6, 12, 13, 14. 14 m1 is equal to 10 minus 6 is 4. Correct? 4 m2. So now I'll take m to the left hand side and 14 to the right hand side. So I'll get m1 by m2 is equal to 4 by 14. So 4 by 14 means 2 1 are 2, 2 7 are 14, 2 by 7. So I could have stopped the answer at this point only. So anyway, in both the case, we are getting the same answer. m1 by m2 is 2 by 7. Exercise 7.2. The next question is question number 5. Find the ratio in which the line segment joining a of 1 comma minus 5 and b of minus 4 comma 5 is divided by the x-axis. Find also the coordinates of the division. So here there are 2 points, and the first point is 1 comma minus 5. That means that is here, somewhere here. Okay, let us say it is okay, it's given as a only. 1 comma minus 5, and b is minus 4 comma 0, minus 4 comma minus 4 comma 5. That means it is somewhere here. Okay, b is here, minus 4 comma 5. Now if I join these 2 points, the x-axis will cut this line, right? So what is the coordinate of this point? Say this is point P. Okay, what is the coordinates of P? P of x comma y. That one we should find. Also we should find the ratio of the ratio of the line segment divided, that is m1 is to m2 I should find. What is m1 by m2 is the question, and also find p of xy is the question. So now p of xy is given by, so what is the midpoint formula? This is equal to m1 x2 plus m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. This is the section formula. So coordinate of P. So since the given line passes through x-axis and P lies on this line and as well as on x-axis, that so y will be 0. Coordinate of y of point P will be 0 because P lies on x-axis. So I'll take P of x comma 0. Now m1 x2 is 1 plus m2 x1 is minus 4 by m1 plus m2 comma, then m1 y2 is minus 5 plus m2 y1 is plus 5 by m1 plus m2 I'll take. Now I'll mark this as equation 1. Now I can equate this with this. So 0 is equal to this one. So I'll equate. So 0 is equal to m1. So m1 into, okay, I'll write as it is first. m1 minus 5 into minus 5 plus m2 5 by m1 plus m2. So if I cross multiply, 0 into m1 plus m2 is equal to, now m1 into minus 5 is minus 5m1 plus 5m2 I'll get. So 0 into m1 plus m2 is 0 only. 0 into any number is 0. So 0 is equal to minus 5m1 plus 5m2. So I'll bring this one to the left hand side. It becomes plus 5m plus 5m1. 5m1 is equal to 5m2. Therefore m1 by m2, if I cross multiply, I'll get 5 by 5 is equal to 1 by 1. So ratio is 1:1. Now I got the value of m1 and m2. If I put this one, I'll get the coordinates of p of x comma y. Okay. Now put m1 is equal to 1 and m2 is equal to 1 in 1. What will I get? P of x comma 0 is equal to 1. m1 is 1, so 1 into 1 plus m2 is 1 into minus 4 divided by m1 plus m2, 1 plus 1 comma m1 is 1 into minus 5 plus m2 is 1 into 5 divided by 1 plus 1. So this is equal to 1 into 1 is 1 plus 1 into minus 4 is minus 4. So minus 4 plus by 2 here. 1 into minus 5 is minus 5 plus 1 into 5 is plus 5 divided by 1 plus 1 is 2. So here 1 plus 1 minus 4 I will get 1 plus, so plus into minus is minus, so 1 minus 4 I will get 1 minus 4 divided by 2. So here plus 5 minus 5 will get cancelled, so 0 by 2 I will get. So again I will get this is 1 minus 4 is 3, minus 3 by 2, so 0 by 2 is 0 only. So coordinates of P is x comma 0, so x is minus 3 by 2. Exercise 7.2, question number 6. If 1 comma 2, 4 comma y, x comma 6 and 3 comma 5 are the vertices of a parallelogram taken in order, find the value of x and y. So there is a parallelogram, maybe it is like this, and the points maybe they are like this. This may be 1 comma 2 and this could be 4 comma y, this could be x comma 6 and this could be 3 comma 5. So I'll call this as A, B, C, D. So in a parallelogram the diagonal bisect each other. Okay, so let the point of intersection be O. Now O is the midpoint of BD, also O is the midpoint of AC. Now midpoint of AC is equal to, so what is the midpoint formula? x1 plus x2 by 2 and y1 plus y2 by 2. So now substitute the value. Midpoint of AC is equal to, so x1 plus x2 is 1 plus x and by 2, y1 plus y2 is 2 plus 6 by 2. So I will get 1 plus x by 2, and 2 plus 6 is 8. 8 by 2, 8 by 2 is 4. Okay, now I'll keep this as it is. Now also the midpoint of BD is again x1 plus x2, that is 3 plus 4 by 2 and 5 plus y by 2. So this is equal to 3 plus 4 is 7, 7 by 2, and y plus 5 by 2. So midpoint of AC is equal to midpoint of BD. Both midpoint are same only. Okay, this I'll mark as 2. That means 1 is equal to 2. So we can equate the right hand side. X term we can equate separately, and y term we can equate separately. So that means 1 plus x by 2 is equal to 7 by 2, and 4 is equal to 5 plus y by 2. So in the right hand side of equation 1, whatever x term is there, that one I am equating. Okay, in right x term of right hand side of 1 and 2 I am equating. Now here this 2 will get cancelled. 1 plus x is equal to 7, or x is equal to 7 minus 1, x is equal to 6 I will get. So here if I cross multiply, 4 into 2 is equal to 5 plus y, 8 is equal to y plus y. So 8 minus 5 is equal to y. 8 minus 5 is 3. So x is equal to 6 and y is equal to 3 is the coordinate of O. Oh, sorry, it's not O. X is the x coordinate of C, that is 6, and y is equal to 3 is the coordinate of y coordinate of point B. And that completes this question. Exercise 7.2, question number 7. Find the coordinates of a point A, where AB is the diameter of a circle whose center is 2, minus 3 and B is 1, 4. So AB is the diameter. Okay, AB is the diameter, and coordinate of B is given. B is 1, 4. So and the center point also is given, that is 2, minus 3. So we should find the coordinate of A. So what is the midpoint formula? Midpoint formula is given by x1 plus x2 by 2 and y1 plus y2 by 2. So here this is x, this is y. So midpoint, that is 2, minus 3 is equal to x plus 1 by 2, y plus 4 by 2. So now we will equate x term and we will equate y term. So 2 is equal to x plus 1 by 2. Cross multiply, 2 into 2 is equal to x plus 1. So 4 is equal to x plus 1. So 4 minus 1 is equal to x. So x is equal to 3. Now if I equate y term, so minus 3 is equal to y plus 4 by 2. Cross multiply, minus 3 into 2 is equal to y plus 4. So minus 3 into 2, 6. So minus 6 I'll get is equal to y plus 4. Bring this one here, minus 6 minus 4 is equal to y. So minus 6 minus 4 is minus 10. So the coordinate of point A is, so point A is 3, minus 10. Exercise 7.2, question number 8. If A and B are minus 2 comma minus 2 and 2 comma minus 4 respectively. Find the coordinates of P such that AP is equal to 3 by 7 of AB and P lies on the line segment AB. So there is line AB and the coordinates of AB are minus 2 comma minus 2 and the coordinates of B are minus 2 comma 4 plus 2 comma minus 4. So I should find a P on point AB, P of xy, such that, so they have given AP, what is that, AP is equal to 3 by 7 times of AB. So when I cross multiply AP by AB, I will get 3 by 7 times, 3 by 7. Okay, so that means if AP is 3, AB is, if AB is 7, what will be the value of PB? Value of PB will be 4. Okay, it is 7 minus 3. 7 minus 3 is 4. Okay, now I'll take AP as M1 and PB as M2 and use section formula and find the coordinates of P of xy. So P of xy is equal to, so I am taking M1 is equal to 3, M2 is equal to 4. P of xy, what is the formula? First write the formula. So M1 x2 plus M2 x1 by M1 plus M2 comma M1 y2 plus M2 y1 divided by M1 plus M2 is the formula. Now substitute the value of M1 M2 and x1 x2 y1 y2 there. So M1 is 3 into x2 is 2 plus M2 is 4 into x1 is minus 2 divided by M1 plus M2, 3 plus 4. Yeah, now next M1 y2, M1 is 3, y2 is minus 4 plus M2 is 4 and y1 is minus 2 divided by 3 plus 4. So I'll get 3 2s are 6, 4 2s are 8, 6 minus 8 by 7 comma 3 4s are 12, so minus 12, 4 2s are 8 minus 8 by 3 plus 4 is 7. So here I'll get 6 minus 8 is minus 2 by 7 and here it is minus 20 by 7. So coordinates of P is minus 2 by 7 and minus 20 by 7. Exercise 7.2, question number 9. Find the coordinates of the point which divide the line segment joining A of minus 2 comma 2 and B of 2 comma 8 into 4 equal parts. So there is a line segment AB and coordinates of A is minus 2 comma 2, coordinates of B is 2 comma 8. So we need to divide this into 4 equal parts. So that means this is half of AB, this be Q. So and half of AQ is, I'll take here P. So and half of QB here PQR. So we should find the coordinates of PQ and R. So all are equal. So now what will be the ratio of AP by AB? Sorry, AP by PB. So here since all are equal, AP by PB will be 1:3. See, all are equal, 1 1 1 1. So here AP is 1 and PB becomes 3. So for coordinates of P is P of xy. So here M is equal to 1 and M1 is equal to 1 and M2 is equal to 3. So now substitute p of xy is equal to, first write the formula, m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2 is the formula. Now substitute the values of m1 m2. m1 is 1, x2 is 2 plus m2 is 3, x1 is minus 2 by m1 plus m2, so 1 plus 3. So here m1 into y2 is 8 plus m2 is 3 into y1 is 2 divided by 1 plus 3. So I'll get 1 2 the 2, so 3 2 the 6, so minus 6 by 1 plus 3 is 4, comma 1 8 are 8 plus 3 2 the 6 by 1 plus 3 is 4. So this is equal to 2 minus 6 is minus 4 by 4, comma 8 plus 6 is 8 6 6 12 13 14 by 4. So here 4 1s are 4, 4 1s are 4, 2 2s are 4, 2 7s are 14. So I'll get minus 1 comma 7 by 2 as the coordinate of P. Now if you take QR, if you take R of xy, here m1 will be equal to 3 and m2 will be equal to 1. Okay, so here substitute here. Now m1 is 3 and x2 is 2 plus m2 is 1, x2 is 2 divided by m1 plus m2, 3 plus 1, comma m1 is 3 into y2 is 8 plus m2 is 1, y1 is 2 divided by 1 plus 3 plus 1. So this is equal to 3 2 the 6 plus 1 2 the 2 by 3 plus 1 4, comma 3 8 the 24 plus 1 2 the 2 divided by 3 plus 1 4. So 4 6 plus 2 is 8 by 4, comma 24 plus 2 26 by 4. So 4 1s are 4, 4 2s are 8, 2 2s are 4, 2 13s are 26. So I'll get 2 comma 13 by 2. So I made a small mistake here. If x1 is minus 2, so here 6 minus 2 I'll get. So 6 minus 2 is 4. So 4, I'll get 4 by 4 comma 26 by 4. So 4 will get cancelled. I'll get 1 comma 13 by 2 as the coordinate of R. Now what is the coordinate of Q? Coordinate of Q is very simple. Now here we can use m1 is equal to 1, m2 is equal to 1, both, because AQ is equal to QB. I can use midpoint formula directly. Midpoint formula is x1 plus x2 by 2 and y1 plus y2 by 2. This is the midpoint formula. So here 2 plus of minus 2 divided by 2, comma y1 is, okay, I've taken x1, okay, whatever it is. Now 2 plus 8. So whether you put x value first or y value or x2 value first, it doesn't matter. Here even in y also, whether you add y1 or y2, it doesn't matter. So 2 plus 8 by 2. So here 2 minus 2 by 2 by uh, comma 10 by 2 I'll get. So this is equal to 0 by 2 comma 10 by 2. So this is equal to 0 by any number is 0 only. So 0. Here 10 divided by 2 is 5. So 0 comma 5 is the coordinates of Q. Exercise 7.2. Question number 10. Find the area of rhombus of its if its vertices are 3, 0, 4, 5, minus 1, 4 and minus 2, minus 1 taken in order. Hint: the area of rhombus is given by half into product of its diagonal. So let the points rhombus is like this. Okay, let the points be 3, 0, 4, 5 and minus 1, 4 and minus 2, minus 1. Okay, now I'll join the midpoints. I'll join the vertices like this so that I'll get a diagonal. So let this be A, B, C and D. Now what is the diagonal? Now AC is given by, what is the formula for what is the distance formula? Distance formula is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So now AC is equal to square root of minus 1 minus 3 the whole square plus 4 minus 0 the whole square. So this is equal to minus 1 minus 3 is minus 4 the whole square plus 4 minus 0 is 4 only, 4 square. So minus 4 the whole square is plus 4, sorry, plus 16. So 4 square is again 16. So 16 plus 16, I'll get 32, square root of 32. Okay, I can factorize this one. So 32 means 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2, 1 2 3 4 5. So I can write 2 into 2 into 2 into 2 into 2. Now I can group like this. Group of 2 I can take one outside here. So 1 2 from this one, 1 2 from this one, 2 into 2 into root 2. This will be left as it is. So 2 to the 4 root 2 I'll get. Now what is the distance dB? Distance dB is given by square root of x2 minus x1, that is 4 minus of minus 2 the whole square plus y2 minus y1, 5 minus of minus 1 the whole square. So this is equal to square root of 4 minus of minus 2 is 4 plus 2 the whole square plus 5 minus of minus 1 is plus 1 the whole square. So here I'll get 4 plus 2 is 6 square plus 5 plus 1 is 6 square. So this is equal to 36, 6 6 are 36 plus 36. So I'll get so 36 into 36 I can write as 2 into 36. Now 36 I can factorize. 36, 2 1s are 2, 2 8s are 16, again 2 9s are 18. Now 3 3s are 9, 3 1s are 3. So root of 2 as it is, 36 I can write as 2 into 2 into 3 into 3. So now I'll make group of 2. This 3 3, this 2 2. I'll take this one outside. So I'll be left with 1 2 from here and 1 3 from here. 2 into 3 into root 2 will be left as it is. So 2 3s are 6. So BD is 6 root 2. 6 root 2. Now what is the area of the rhombus? Area of the rhombus is given by half into product of the diagonal. First diagonal is 4 root 2. Second diagonal is 6 root 2. So here 2 1s are 2, 2 2s are 4. Now again 2. So I am left with 2 into root 2 into 6 into root 2. Now this I can write 2 into 6 into root 2 into root 2. So this is 2 into 6. So root 2 into root 2 is 2 only. Okay. So 2 2s are 4, 4 6 are 24. So 24 square unit. So area of this rhombus is 24 square units. And that completes this problem and this exercise. The next topic in this chapter is area of triangle. See here, you can see this figure. There is a triangle ABC. Coordinate of A is x1 y1 and coordinate of B is x2 y2 and coordinate of C is x3 y3. So same diagram I have written here. So you can see now I should find the area of this triangle. Okay. To find the area, what I'll do is I'll draw perpendicular from point A from point B and from point C. I'll draw perpendicular to x-axis and I'll call those points as Q, P and R. So perpendicular means they make an angle of 90 degree to the x-axis. Now you can see that there are 4 trapezium. First trapezium is ABQP. Second trapezium is APRC and the third trapezium is BQRC. Now from the figure it's very clear that area of triangle ABC is nothing but if you add the area of this trapezium and also if you add the area of this trapezium and if you subtract the area of this trapezium, you will get the area of triangle ABC. That is, area of triangle ABC is given by area of trapezium ABQP plus area of trapezium APRC and minus area of trapezium BQRC. And area of trapezium is given by area of trapezium, area of any trapezium is given by half into sum of parallel side. Sum of parallel sides into distance between them. Distance between the parallel sides. Okay. Parallel sides. So here now what is the area of trapezium ABQP? So this is equal to half sum of parallel side. Parallel side is BQ plus AP. So into distance between these two parallel lines is QP. Okay, QP. Then plus now area of trapezium APRC is half sum of parallel side. Parallel side of APRC is AP plus RC. Okay, and into distance between side AP and RC, that is PR. Now minus area of trapezium BQRC. Now here sum of parallel side is BQ plus RC. So into the distance between BQ and RC is QR. Okay. Now here this is equal to half. Now BP plus AP, BQ plus AP is equal to Y2 plus Y1, and QP is nothing but x1 minus x2 plus half. Now what is AP? AP plus here, AP is nothing but y1 plus y3 plus y3, and PR is nothing but x3 minus x1 minus half of, now BQ plus RC. BQ is nothing but y2 and RC is nothing but y3 into, now what is QR? QR is nothing but x3 minus x2. Now you open the bracket, so this is equal to half into, now multiply y2 plus y1 into x1 minus x2. Now I'll take half as common factor, okay, everywhere. So now y2 into x1 is y2 x1 plus y2 x2, sorry, y2 x2 I'll get, plus y2 x1 minus y1 x2, now plus y1 x3 minus y1 x1 plus y3 x3 minus y3 x1 minus y2 x3 plus y2 x2 minus y3 x3 plus y3 x2 I'll get. Now here you can see, you can cancel some terms. Y2 x2 minus y2 x2 will get cancelled with plus y2 x2, and minus x1 y1 will get cancelled with plus x1 y1. Where is that? So that is here, this is x1 y1, so these two will get cancelled. Then x3 y3 will get cancelled with x3 y3 here. Now I am left with 1 by 2 into y2 x1 minus y1 x2 plus y1 x3 minus y3 x1 minus y2 x3 plus y3 x2. Now here again, this is 1 by 2. From these two I can take x1 common. So x1 into y2 minus y3 will be left, plus again from x2, from this and this, okay, from this and this I can take x2 common. If I take x2 common, I'll get y3 minus y1. Now the remaining is this and this. So in this one I can take x3 common. If I take x3 common, I'll get y1 minus y2. So this is the area of the triangle. So go through the text. I have given the same explanation as given in the textbook, and in textbook there are some worked examples. See here in this question, we should find the area of the triangle formed between these 3 points, among these 3 points, that is 1 comma minus 1 minus 4 comma 6 and minus 3 comma 5. So just substitute the given values in the formula, you will get the area. Here they are getting 24 square units, and in this question also is very easy. We should find the area formed by these 3 points. So this is just direct question. So they are substituting the values of A, B and C in this formula. They are getting the area. So here see, area they are getting minus 2 square units, but area can't be negative, therefore they will take positive. Okay. So and this question also, it's a direct question. Find the area of the triangle formed by the points P, Q and R. Just substitute the values of x and y in the given formula. You will get the, okay, here area they are getting 0. Okay, if area is 0, then what it means, they all the 3 points are in a straight line. Okay, now find the value of k if the points A, B and C are collinear. So if 3 points are collinear, that means collinear means all the 3 points lie in the same straight line. So if in this case the area will be 0, so they will put all the values of x and y in the formula and equate the area to 0. Now they are getting k is equal to 0. That's what the question in this one. Find the value of k. So and in the last question you can see, find the area of the quadrilateral. In quadrilateral you can take 2 triangles in that one, and if you add the area of those 2 triangles, then you will get the area of the quadrilateral. So similarly in the quadrilateral ABCD, they have taken ABD as one triangle and BCD as one triangle, and they calculate the area separately. First triangle's area is 53 square units, second triangle's area is 19 square units. So this plus this gives 72 square units. It's all self-explanatory. You can go through it. I'll be directly solving the exercise problem. Exercise 7.3, question number 1. To find the area of the triangle whose vertices are, first sub question, the vertices are 2, 3, minus 1, 0 and 2, minus 4. So I'll take these points as A, B, C. So now triangle area of triangle ABC, so is given by half into, write the formula first, x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is the area of the formula for the area. Now substitute all the values. x1 is 2, y2 is 0, y3 is minus 4. Okay, now plus x2 is minus 1. Okay, then y3 minus y2, y3 is minus 4, y minus y1 is 3 plus x3 is 2, then y1 minus y2, that is 3 minus 0, so we'll get 1 by 2. So this 2, so 0 minus of minus 4 is plus 4, so 0 into 4 I'll get plus, so minus 1 into minus 4 minus 3 is minus 7 plus 2 into 3 minus 0 is 3 only, so 1 by 2 I'll get 2 4s are 8, then minus 1 into minus 7 is plus 7 plus 2 3s are 6. So half into 8 plus 7 plus 6 is 8 8s are 16, 8 3s are 24, 25, 26, 27 I'll get, is it 27? Sorry, it's 21, 6 3s are 18, 19, 20, 21, so into 21. So this is 21 by 2 square units is the area of the triangle ABC. Now second sub question. So the given points are minus 5, comma minus 1, 3, comma minus 5, and then 5, comma 2. So this is a direct question. I'll take point ABC. Now area of ABC, area of triangle ABC is given by half into, first write the formula, x1 into y2 minus y3 plus x2 into y2 minus y1 plus x3 into y1 minus y2. Now substitute the value, half x1 is minus 5, so minus 5 into y2 minus y3, that is minus 5 minus 2 plus x2 is 3 y2 minus y1, that is minus 5 minus 1 second. So this is y3. Okay, so now x2 is 3. Now y3 is 2. y3 2 minus y1 is minus 1. So 2 minus of minus 1 plus x3 is 5. Then y1 minus y2, that is minus 1 minus of 3. Okay, now this is equal to half. So minus 5. So minus 5 minus 2 is minus 7 plus 3. 2 minus of minus 1 is 1. 2 plus 1 I'll get. So that is 2 plus 1. One more step I'll write. Plus 5. So minus 3 minus minus 1 minus 3 is minus 4. So this is equal to half. Now minus 5 into minus 7 is 5 7 are 35. I'll get plus 35. Okay, now plus here 2 plus 1 3. 3 plus 3 sorry 3 into 3 is 9. Next 5 4s are 20. So minus 20. So here I made a small mistake. Minus 1 comma, it's minus 5. This is y2. y2 is minus 5. Minus of minus 5 it is. Okay, so minus of minus 5. So that means 5 into 1. So I'll get here 5 into minus 1. Minus into minus is plus. Plus 5 I'll get. Okay, now this is minus 1 plus 5 is plus 4. Then 4 5 is 20. Plus 20 I will get. Okay, so this is half. So 35 30 40 50 59 60 64. So 1 by 2 into 64 I'll get. So I can divide 2 3s are 6, 2 2s are 4. So 32 square units. Square units is the area of the triangle ABC. Exercise 7.3, question number 2. In each of the following, find the value of k for which the points are collinear. So points are 7 minus 2, 5 comma 1 and 3 comma k. So I'll take these points are A, B, C. See if ABC are collinear, then collinear means they lie on a same straight line. So if they lie on same straight line, the area formed by this triangle ABC is 0. So now area of ABC, area of triangle ABC is given by, first write the formula, 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y2, sorry y3 minus y1 plus x3 into y1 minus y2. This is the formula. Now substitute the values of x and y. So this is half. x1 is 7. First that is the x coordinate of A. So 7 into y2 minus y3. y2 minus y3 is 1 minus k plus x2 is 5. y3 is k minus y1. y1 is minus 2. So k minus of minus 2. Okay, then plus x3. x3 is 3 into y1. y1 is minus 2. minus 2 minus of y2. y2 is 1. So this I'll get. So given the area is, if they are collinear, then the area will be equal to 0. So I'll equate it to 0. So 0 is equal to half into 7 into 1 minus k plus, so here 5, k minus of minus 2, minus of minus 2 is plus 2, then plus 3. Now 3 minus 2 minus 1 is minus 3. I'll get addition. Okay, now I'll cross multiply here. So 0 into 2 is equal to 1 into this one. So 1 into 7 1 minus k plus 5 into k plus 2 plus now 3 into 3 is 9, so minus 9 I'll get. Okay, so 0 into 2 is 0 only. Now 1 into this thing is the same thing I'll get, so I'll get 7 into 1 minus k plus 5 into k plus 2 minus 9 I'll get. So now open the bracket, so 7 into 1 is 7 minus 7 into k is 7k plus 5 into k is 5k plus 5 2s are 10 minus 9. So how much I'll get? 7 plus 10 minus 9, so 10 minus 9 1, so 8, then k minus 7k plus 5k is 2k. So now I'll bring 0 is equal to 8 minus 2k, so I'll bring this 8 to left hand side, I'll get minus 8 is equal to minus 2k. So or k is equal to minus 8 by minus 2, minus will get cancelled, 2 1s are 2, 2 4s are 8, k is equal to 4 is the answer. The second question, I'll take points as A, B, C. So now area of triangle ABC is given by half. So half into, write the formula first, x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So always if you write the formula, it's very easy to solve, otherwise you will get confused. So 1 by 2 into, so area, if these 3 points are to be collinear, then the area will be equal to 0. So in the left hand side I'll put 0. So x1 is 8, then y2 is minus 4 minus y3 is minus 5, so minus of minus 5. Okay, plus x2 is k into y3 minus y3 is minus 5 minus y1 is 1 plus x3 is 2 y1 minus y2, so y1 is 1 minus y2 is minus 4, so 1 minus of minus 4. Okay, now I'll cross multiply, 0 into 2 is equal to 1 into, now what I'm left, 8 into minus 4 minus into minus 5 is plus 5 plus k, now minus 5 minus 1 is minus 6 plus 2 into 1, minus of minus 4 is plus 4. So 2 into 0 is 0 only, so this is 1 into, now 8 minus 4 plus 5 is plus 1 I'll get. So it is subtraction, 5 minus 4 is 1, sign of the greatest number, that is 5 is the greatest number, though therefore plus will be the sign, plus. So here k into minus 6, okay, I'll take directly minus 6, k plus k into minus 6 is minus 6k plus, now here 2 into 1 plus 4 is 5. Now again 0 is equal to, so 1 into this thing is same, so I'll get, now here 8 into 1 is 8 minus 6k, 2 5s are 10 plus 10. Okay, now 8 plus 10 is 18, so 18 minus 6k is equal to 0. Therefore I'll take 18 to the left hand side, so it becomes minus 18 is equal to minus 6k, so or k is equal to minus 18 by minus 6, so minus will get cancelled, 6 1s are 6, 6 3s are 18, k is equal to 3. So for value k is equal to 3, the triangle formed by the points ABC will be 0. the area of the triangle formed by the points A, B, C will be 0. Exercise 7.3, question number 3. Find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are 0, minus 1, 2, 1 and 0, 3. Find the ratio of this area to the area of the given triangle. Now let the points be like this. A is 0, minus 1, B is 2, 1 and C is 0, 3. Now let the midpoint of AB be D, and let the midpoint of BC be E, and let the midpoint of AC be F. Now if I join the midpoints, I'll get another triangle. Okay, now I should find the ratio of the triangle of the ratio of the areas of the triangle ABC to the area of the triangle DEF. So I should find ratio of triangle ABC to area of the triangle DEF. So before doing this, I should find the midpoint of AB, BC and AC. So what is the midpoint formula? Midpoint formula is given by x1 plus x2 by 2, y1 plus y2 by 2. Okay, now the midpoint of AB is 0 plus 2 by 2, comma minus 1 plus 1 by 2. So I'll get midpoint is 2 by 2, comma, so this minus 1 plus 1 is 0, so 0 by 2, so 2 1s are 2, 2 1s are 2, so 1, 0 is the midpoint of AB, that is the coordinate of D. Now midpoint of BC is equal to 2 plus 0 by 2, comma y1 plus y2 by 2, that is 1 plus 3 by 2. So this is equal to 2 by 2, comma 4 by 2. So 2 1s are 2, 2 1s are 2, here 2 1s are 2, 2 2s are 4. So 1, 2 is the coordinate of E. So now midpoint of AC is given by x1 plus x2 by 2, that is minus 1 plus 0 by 2, sorry 0 plus 0, okay, 0 plus 0 by 2, comma minus 1 plus 3 by 2. So this I'll get 0 by 2, minus 1 plus 3 is plus 2, 2 by 2. So here 2 will get cancelled. I'll get 0 by 2 is 0 only, so 0, 1. So coordinates of DEF are 1, 0, 1, 2 and 0, 1 respectively. Now what is the area of DEF? Area of DEF is given by, what is the formula? Write the formula, that is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is the formula. First always write formula and then proceed. So 1 by 2. So I am taking point DEF. So x1 is 1 into y2 is 2 minus y3 is 1 plus x2 is 1, then y3 minus y1, that is 1 minus 0 plus x3 is 0, y1 is 0 minus y2 is 2. So here I'll get half into, so 1 into 2 minus 1 is 1 plus 1 into 1 minus 0 is 1 only, plus 0 into any number is 0 only. So this I'll get half into, so 1 into 1 is 1 plus 1 into 1 is 1 plus 0. So again I'll get 1 plus 1 2 divided by 2 divided by 2 I'll get, so 2 ones are 2, ones are 2, so I'll get 1 square unit. Okay, area of triangle DEF is 1 square units. Now I'll find the area of triangle ABC. Area of triangle ABC is given by formula already I have written, so I'll just substitute the values here. x1 is 0. First I'll take x1 y1 I'll take as a coordinates of a. Now 0 into y2 is 1 minus 3, then plus x2 is 2 into y2 minus y3, x2 y3 minus y2, that is y3 is 3 minus minus of minus 1, then plus y3 x3 is 0, plus y1 minus y2, that is minus 1 minus of 1. Okay, so this is equal to half into 0 into 1 minus 3 is minus 2, plus 2 into 3 minus of minus 1 is 3 plus 4, minus of minus 1 is plus 1, so 3 plus 1, plus 0 into minus 1 into minus 1, minus 1 is minus 2, we need to add. So now this I'll get as half into, so 0 into minus 2 is 0 only, then plus, then 3 plus 1 is 4 into 2 is 8, plus again 0 into any number is 0 only, so I'll get half into 8, so 2 ones are 2, 2 fours are 8, so 4 square units. So what is the given question? We should find the ratio of the area of the areas to the area of the given triangle. That means area of DEF by area of ABC is equal to 1:4. Area of DF I got as 1 square unit, and area of ABC is I got 4 square unit. So the ratio of the area is 1:4. Exercise 7.3, question number 4. Find the area of the quadrilateral whose vertices taken in the order are -4, -2, -3, -5, 3, -2 and 2, 3. So I've drawn the quadrilateral, you can see, and I've taken points on the vertices as shown. Let -4, -2 be A, and here this be B, and this be C, and this be D. So you can take in any order, that's not an issue. Now I'll join A and C. Now I'll get two triangles, that is triangle ABC and triangle ACD. If I add the area of these two triangles, I'll get the area of the quadrilateral. Okay, now what is the total area? Total area is equal to area of triangle ABC plus area of triangle ACD. Okay, now what is the formula for area of triangle ABC? So first write the formula, half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula. Now substitute the values. So x1, so I'll take x1 y1 as point A. So I'll get -4 into, so x2 y2 I'll take B, point B, and x3 y3 I'll take as point C. So y2, now here it is -5 minus of -2, then plus x2 is -3. Okay, y3 minus y1, y3 is minus 2, minus of minus 2 I'll get, okay, plus x3 is minus 2 into y1 minus y2, that is minus 2 minus of minus 5. Okay, now this is equal to 1 by 2 into minus 4, so into minus 5, so minus of minus 2 is plus 2. Then so here plus into minus, I can take minus 3, then minus 2, so minus of minus 2 is plus 2, plus, so plus, okay, this I'll take in bracket. Now plus into minus is minus, so minus 2 into, now minus 2, minus of minus 5 is plus 5. Okay, so this is equal to half into minus 4, so minus 5 minus 5 plus 2 is minus 3. Now minus 3, so minus 2 plus 2 is 0, I'll get. Then now minus 2, so here one mistake I've made, this is plus 3. Okay, so this is 3, so plus 3. Now minus 2 plus 5, minus 2 plus 5 is plus 3. Okay, now half into, now 4 3s are 12, minus into minus is plus, so plus 12 I'll get, minus 3 into 0 is 0 only, plus 3 into 3 is 9, plus 9, so I'll get half into 12 plus 9 is 21, so I'll get 21 by 2 square units as the area of triangle ABC. Now area of triangle ACD, is equal to half. Now I'll take x1 y1 as A, x2 y2 as C, and x3 y3 as D. Now half into, so x1 is minus 4 into y2 minus y3, so y2 is minus 2, minus y3 is 3, then plus x2 is 3, then y3 minus y1, y3 is 3, minus of y1 is minus 2, so minus of minus 2, then plus y3 is, sorry, x3 is 2, and y1 minus y2, so y1 is minus 2, minus of y2 is minus 2, so minus of minus 2 I'll get, so this is equal to half, so minus 4, so minus 2 minus 3 is minus 5, so we need to add 2 plus 3 is 5, sign of the greatest number, that is minus, so plus 3 into, so here 3 minus into minus is plus, 3 plus 2 I'll get, then plus 2 minus 2, so minus into minus is plus, I'll get there, so this is equal to half. So here minus 4 into minus 5, 4 5s are 20, minus into minus is plus, so plus 20 I'll get, so plus here 3, so here 3 plus 2 is 5, plus, now here minus 2 plus 2 is 0, so 2 into 0, so this is equal to half into 20 plus 3 5s are 15 plus 0, so 20 35, so I'll get 35 by 2 square units. So now total area or the area of the quadrilateral is given by area of triangle ABC plus area of triangle ACD. So this is equal to area of triangle ACD is 21 by 2, and the area of triangle ACD is 35 by 2. So LCM is 2. Okay, now 21 plus 35. So how much? 30, 40, 50, 56, 50 by 56 by 2. So this is equal to 56 by 2. I can divide by 2. 2 1s are 2, 2 2s are 4, 2 8s are 16. So ultimately I'll get 28 square units. So area of the quadrilateral is 28 square units. Exercise 7.3, question number 5. You have studied in class 9th, chapter 9, example 3, that a median of a triangle divides it into two triangles of equal areas. Verify the result for the triangle ABC, whose vertices are 4, minus 6, B 3, minus 2, and C 5, 2. So the vertices are taken like this in this triangle. You can see the figure. Now if D is the midpoint of BC, okay, if D is the midpoint of BC, and if I join A and D, AD is the median. Okay, so let D be midpoint of BC. Therefore AD is the median. Now what is the coordinates of D? So see, D is the center point. Therefore what is the formula for center point? Midpoint. So midpoint is given by x1 plus x2 by 2, comma y1 plus y2 by 2. So now D of x comma y will be equal to, so x1 plus x2, that is 3 plus 5 by 2, comma minus 2 plus 2 by 2. So 3 plus, this is 8 by 2, comma, so minus 2 plus 2 is 0, 0 by 2. So 2 1s are 2, 2 4s are 8. So 4, 0 is the coordinates of point D. Okay. Now I should verify that the area of triangle ABD will be equal to area of triangle ADC. So in any triangle this is true. If there is a median, as shown in the figure, if AD is the median of this triangle ABC, then area of triangle ABD is equal to area of triangle ADC. So let us check whether this is true or not. So now area of triangle ABD is given by, first write the formula. Formula is x1 into y2 minus y3 plus y1 into plus x2. So x2 into y2 y3 minus y1 plus x3 into y1 minus y2. This is the formula for area. Now substitute the values. So I'll take x1 y1 as A, x2 y2 as B, and x3 y3 as D. So now here x1 is A, x1 is 4. So 4 into y2 is minus 2 minus of 0 plus x2 is 3, then y3 minus y1, that is 0 minus of minus 6, plus x3 is 4 into y1 minus y2, that is minus 6 minus of minus 2. So this is equal to half. So 4, so minus 2 minus 0 is minus 2 only, plus 3 into, so 0 minus of minus 6 minus of minus 6 is plus 6, so plus 6 plus 4, so minus 6 minus of minus 2 is plus 2. So this is equal to half. So here 4 2s are 8, so minus 8 I will get, plus 3 6 are 18, plus 18. So here 4 into minus 6 plus 2 is minus 4. So one more step of simplification I am writing, 1 by 2 into minus 8 plus 18. So here 4 4s are 16, minus 16 I'll get. So totally I'll get 1 by 2. So minus 8 plus 18 minus 16 is minus 8 plus 2. I'll get minus 6. Okay. So 2 1s are 2, 2 3s are 6. So I'll get minus 3. So area can't be minus 3. So we'll take area to be positive only always. So area of ABD is equal to 3 square units. So now what is the area of triangle ADC? So formula already I have written. I'll just go and substitute. I'll take x1 y1 as 4 comma minus 3, that is point A, and x2 y2 as point D, and x3 y3 as point C. So here 4, x1 is 4 into y2 minus y3, that is 0 minus 2, plus x2 is 4, plus y2 minus y3, sorry, here y3 minus y1, so that is 2 minus of minus 6 I'll get. Then plus x3 is 5, then y1 minus y2, that is minus 6 minus 0. So this is equal to half. So 4 0 minus 2 is minus 2 only, then plus 4. So 2 minus of minus 6 is plus 6, plus 5 minus 6 minus 0 is minus 6 only. So this is equal to half. So here 4 2s are 8, minus 8, plus here 2 plus 6 is 8, 8 4s are 32, then 5 6 are 30, plus into minus is minus 30. So this is equal to half. So minus 8 plus 32, minus 30 is minus 8 plus 2 I'll get minus 6. Again here minus 6 I'll get. 2 1s are 2, 2 3s are 6. So minus 3. So area can't be negative. So area I'll take positive only. Area of ADC is equal to plus 3 square units. So now it is clear. See, this I'll take 1 and this I'll take 2. From 1 and 2 we can clearly say that area of triangle ABD is equal to area of triangle ADC, and that completes the proof. This is actually, we need to prove it, and we have done that. That ends this proof. In this proof there is one more point that you need to note down. So in any triangle there will be 3 median. Okay, so like this, if you take midpoint of base as this one, so this is one median, and also this is one median, and also this is one median. So no matter what median you take, this proof will hold true. So the next topic is optional exercise. So this is beyond your scope, just for your understanding they are given. I don't think so this will come in examination, so I'll be skipping this. And summary. So in this chapter what we have learned, first thing that we learned is distance formula. If coordinates of P is x1 y1 and coordinates of Q are x2 y2, then the distance between P and Q is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, the distance of a point P. Okay, and if P is any point on xy plane, then that the distance of origin and P is given by square root of x square plus y square. So and if P divides the line joining A and B internally in the ratio of m1 is to m2, then the coordinates of P of xy is given by m1 x2 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. Okay, and if P is the midpoint of, sorry, if there is a midpoint on the line joining P and Q, then the midpoint is given by x1 plus x2 by 2 and y1 plus y2 by 2. And if there are 3 points x1 y1 x2 y2 x3 y3, and the area of the triangle formed by these 3 points is given by this formula, that is 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And that completes the summary and this chapter.